smoke those are the same that smoke. But science is all about challenging assumptions, right? And saying, is that really so? So the exercise we're going to do today is to say, how does the prevalence of any tobacco product use and any combustible tobacco product use change when we include or do not include RYO cigarettes? And is it true that the characteristics of those who use RYO cigarettes are exactly those who use regular cigarettes? Does the research question make sense to you in your mind? Are you clear of what we're trying to achieve? Okay. So the first thing we're going to do is not jump into the data immediately and start analyzing. The first thing we're going to do is to start up with an idea of our statistical analysis plan. How many of you have heard of that term before? It's SAP, statistical analysis plan. What does it mean to you?
First of all, define the variables that you're going to use from the data set, like which cycle you're going to use, the actual variables that you're using, exposure, outcome, any potential variables that you're going to look, all the variables. And then you would define how would you do like your descriptive statistics, and then before that, maybe how you're going to check your data for like, is it normally distributed for distribution? Then descriptive statistics, what kind of descriptive statistic you would use for each variable, and then bivariate and variate analysis, and lastly, your multivariate analysis, which is spectral regression.
Okay. Any other thoughts, or are we all fully in agreement with that? So I've never just dive into analysis without first of all having an idea of what you're trying to analyze, right? It's always a good idea to come up with table shells. Have you heard of table shells? Table shells are just like, as the name implies, empty shells. But you come up with a table that says, here is my table one, here's what's going to look like, right? I'm going to have these variables. That allows you to put some thought into the process of some ideation into the manuscript process. So it's not just some random event, right? You are really putting thought into it. So the first thing we're going to do now is to ideate our manuscript and say, here are our tables, and here is what they're going to look like. Given the research question, here is what we want to look like. So here's the major aim, the objectives. Here's table one, what's going to look like. I mean, they're called table shells because they're just shells. They don't have data in them, but it helps you to conceptualize and to refine your thoughts very clearly, right? So that's what we're going to do. So I'm going to open a Google document now, and we will, let me open the document, and so let's open a new documentation document. And let's talk about, let's just call this ideation, the manuscript ideation. So not everything on the Chi-Square platform is about manuscripts. So this document type is just for documentation. So if you're trying to like make notes, so we're going to use that to ideate for our manuscripts. So our title, the title of our manuscript is, it doesn't have to be fancy, right? Have you heard of the concept of FBR? FBR. Have you heard of that before? It means fast, bad, and wrong, right? That's how you want to write at the beginning. You don't want to, this is the hallmark of new writers. They write one paragraph and then they admire that paragraph and change the fonts and go back to read again. No. That's not how to write, okay? We're going to use the FBR style. We're going to have a very ugly draft, and that's good. That's what we want. And then we're going to refine it. So that's FBR. So our title doesn't have to be perfect, but the idea is, how does including roll your own cigarettes in the definitions in measures of current any tobacco use and current any combustible tobacco use change the prevalence of tobacco use among US middle and high school students. Again, at this point, the goal is to capture as much information as you want. The goal is not to make it fine or fancy or cool or anything. No, just type. Just take your ideas from your brain and put them on paper. That's what we want at this point. So that's our title for now. How does including roll your own cigarettes in prevalence measures, how does that change prevalence? So that's what we're trying to capture. All right. So the data set, we're going to use the NYTS, National Youth Tobacco Survey. National Youth Tobacco Survey. Now, in 2018, the NYTS turned into an electronic surveillance system. Before then, we're using paper and pencil questionnaires. Right. When you think of roll your own cigarettes, what kind of demographic immediately jumps to your mind as being potential users? What kind of people in general, the first thing in your mind?
Adults.
Adults, but what demographic? Rich, poor, middle class?
Oh.
Yeah. So you think of, okay, people using roll your own cigarettes, perhaps as maybe because they're price sensitive, maybe because they cannot afford manufactured cigarettes, right? And when you have changes in methodology, you want to think of the consequences of such changes. Are poor people more likely to participate in an electronic survey or not? What do you think? Less likely. So if we had a change in methodology of NYTS, that from 2018, they switched to an electronic survey. And the question we're trying to explore really is just about methodology, right? It's not necessarily about whether it's, we don't really care so much about whether it was 2017 or 2020, but we want to use the data that this would give us remember yesterday we said research is a pursuit of what? Truth, right? So which would give us more truth, right? Which would give us more precision? Should we use a data set that was captured electronically, or should we use the one that used paper and pencil? Again, research is all about making a lot of decisions, right? Which would make more sense to you? Paper and pencil, exactly. So that means that in this case, I might say, I have the option to use many waves of the NYTS. I could use the recent waves that they had electronic capture, but maybe not. Maybe kids who use roll your own cigarettes may not appear in those surveys in great number, or maybe even if they answer the survey, maybe they're not familiar with technology so much. Whatever the reason, right? But you have to make a decision. Research is about making a lot of small decisions. So in this case, I can decide that, well, for the purpose of this survey, I'm not necessarily interested in, my research question is never about what is the recent prevalence of roll your own cigarettes. No, if that were the question, then I will have to use a more recent data sets. The question is inherently about methodology. How does case definition influence the prevalence estimates? Does including or not including RYO change prevalence dramatically? So I should use the data set that would best answer that question. So in this case, we are better off using the NYTS cycle that preceded electronic capture. So we're going to use 2017, right? So when you make decisions like that, you should always be ready to defend them. Because a reviewer would, for good reason, ask you, why are you using 2017 wave when we have 2018, 19, 20, 21, 22? You have to be able to defend that decision. Science is all about making decisions that are defensible. Exactly. Right. Exactly. All right. So NYTS, we're going to use 2017 wave. Yes, please. Yeah.
I don't know if I have the subscription. Did you add?
Okay, maybe was his email among the ones you sent? Okay, no.
No.
Okay, let me ask.
Sorry,
for
I
yours.
thought you guys were friends.
That is hilarious. I thought you were watching out for his interest too. Which email are you using?
The HSDM.
Okay. If you can just let me type it here. Lungile, please we need one more email. Let me drop it for you.
Are you using the SAS format for your what data set are you using in the SAS to download? She's gonna
Okay,
use-
okay, we'll come back in just a second. Let me just quickly
Don't give me your phone number.
Okay, so let me untop it for you here. Where is the message? You just type it there. Somewhere at the top there. Very long emails.
Yeah.
The risk for error increases exponentially. All right. So we're going to use the 2017 cycle. All right. So what are the justifications for using the 2017 NYTS?
Because it's the last one that has paperwork.
Exactly. Because this is the last most recent wave. So this is the most recent PAPI. Are you familiar with PAPI? If you take survey methodology, we mean paper and pencil interview.
Oh.
So so that's the most recent wave that utilized paper and pencil methodology. So it makes sense for us to, yes, go ahead.
So like, for example, like people who's using different ones, can I use like the recent one just, and my justification is because it's the most recent one and
Yeah, the research question should drive every other thing, right?
Yeah.
If the research question is what are recent estimates of smokeless tobacco of roll-on cigarettes, then it would make sense to use the most recent one.
Okay.
Does that make sense?
Yes, that's what I
Yeah. So for this exercise, we're going to use the 2017 cycle of NYTS. All right. What variables do you think will be very important for us to capture? Remember, we talked yesterday about the causal inference framework and why we want to capture, outcomes and our main exposure. And now, even if your research is exploratory, it's always very good to frame it in a causal framework so that you have main exposure and an outcome and then confounders. It allows you to just think about it much more broadly. You understand? So here, our primary outcome is what? What do you think? Or okay, if that's confusing to you, let's just list out all the outcomes we're interested in. So what are they?
Any tobacco use.
Okay, any tobacco use. And remember, we're interested in the question, how does including or not including RYO affect the estimates for any tobacco use? So we're going to look at any tobacco use. Now, I need you to add a clause to it. Any tobacco use with RYO, any tobacco use without RYO.
Yeah.
Does that make sense? So any tobacco use with RYO. So in other words, we're looking at the following products: those who use cigarettes and cigars and pipes and BDs and hookah and
Okay.
yes, electronic cigarettes and chewing tobacco and snus and dissolvable tobacco products, DTPs. Have I omitted anyone? Cigarettes, cigars, pipes, BDs, hookah, e-cigarettes, chewing tobacco, snus. I think I've covered all, of course, and RYO in this case, right? Because that's the first definition of any tobacco use we're interested in. Now, what's the second one? Any tobacco use without RYO. So again, everything here except this one, right? Then the next set of definitions will be what? Any combustible. Any combustible. So these are standard definitions we use in federal surveillance systems. Any combustible. So you know what a combustible product is, right? Yeah, anything that burns, that produces smoke or a flame. Combustible. So which products here aren't combustible? Cigarettes is combustible, cigars is combustible, pipes is combustible, BDs also, hookahs, yes, e-cigarettes are not combustible, chewing tobacco are not, snus and dissolvables are not. So we're going to remove them. And the same thing here. Is there anyone who's lost so far? Are we all good so far? We're good? Okay. It would also be nice to look at, cigarette smoking prevalence, just cigarette smoking prevalence. Current. RYO smoking prevalence. Current. And also ever, right? Since we're focused on just usage patterns, in this case, it will be also interesting to look at just ever usage. So apart from current usage, ever usage as well. That could also be of interest. So current, but also ever. So now the variables you choose and how you construct them must be aligned with the original aims. Now we had the title, but let's take a step back and let's go back and restate our aims very clearly. Remember that the dog must wag the tail. It's quite absurd if the tail was wagging the dog, right? So the dog always has to wag the tail. Our research aims must drive our approach and everything we do, right? So let's go and state our aims. So what do you think are the aims for this research project? How many aims should you have in your research in general? Yeah, you can have one aim, that's fine. There's no crime against having one aim. You can have two. You can have when is too much, too much? When does it start getting too much? After 3 years, it's like, okay, shouldn't this be 2 papers? Like, oh, here are the aims of this paper, aim 1, aim 2, aim 3, aim 4, aim 5. It's like, really? Is this still one paper or is this so that's becomes too much. So try to keep it between 1 and 3, right? All right. So in this case, what are our aims? What's aim 1? Okay. So when we're expressing aims, we always want to use action words, like verbs. So in this case, to do what? Yeah. To assess, but we're looking at the prevalence of 2 different constructs, right? Exactly. So we're comparing prevalence of current, usage patterns when we include or do not include RYO cigarettes, right? But the point is try to frame your aims in a very action-oriented manner. So here we can, and again, there's no hard and fast rule on how you want to say that. You can say that however you want. But let's say to compare tobacco use prevalence estimates. When RYO products are added to the case definition versus when they are not added, right? And the definitions we're interested in are current any tobacco use, current any any combustible use, and as well as compare the individual usage patterns. So that's one aim. So bottom line is simple. how does the prevalence change when we include or do not include these products? Do you think that's an important question from a public health perspective? Why so?
Because if it changes it, then that means the RYO use is like. I don't know if the word is significant there.
Yeah.
Yeah.
Yeah. Why do we communicate? Why do we write reports like this and say that, for example, in this report here, we say 19% in 2024, 19% of US middle and high school students reported ever used any tobacco products. Why do we publish reports like this? What's the use of that number, 19%? Okay. Who do you think works? Who's our target audience with this kind of reports? Because we have to understand the so what.
Tobacco, not tobacco companies. They don't care.
Well, they do. They're like, okay, we have a good market, right? Policymakers, exactly. Policymakers care about that. Who else? Exactly. Grassroots organizations, people who work with youth. So do you think it matters if you said 19% versus if you said 21%? Does it matter? It does, of course, it
Because we're
does.
talking about that big population.
Exactly.
Yeah.
It does, and even the sense of urgency, right,
Yeah.
changes when you say,
That's
oh,
why people sell something $39.99 versus telling you that they're selling something
exactly.
$400, right? Or $39.99 or $399,
Mhm.
Instead of saying that they're selling something $400, they will sell you something for $399, which is essentially the same.
Exactly.
But,
Framing matters, right? So it's a non-trivial issue if we reported a prevalence of 19 versus 20 or 20 versus 21. So if exclusion of a product makes that kind of change, yeah, we care about it. Means, we should then start including it. So that's a major recommendation, right? That our estimates of any tobacco use are grossly underestimated. And that we recommend that going forward, federal government's reports should include that product. Yeah, that's an important report or recommendation from. It's not every time you write a paper that you get to make that kind of profound recommendation. So it's important, right? All right, so let's look at apart from remember that the current practice is based on an assumption. When you're coming up with your aims, the aims should reflect real-world priorities. Again, remember that what is the assumption for RYOs not being included in current reports? What is the implicit assumption? Like this current reports, like if you look at go to the reports, cigarettes are included, but not RYO cigarettes, right? Why do you think that is the case? What is the implicit assumption behind that practice?
Yeah.
The thing, what is the same?
Are there any tobacco product?
So I think cigarettes or RYO cigarettes are the same. Or let's step behind that. If we're not talking about the products being the same, what are we saying in effect? Excellent. A shift from products to people now. Right. In the data set, can we empirically test questions about the product being the same? Like think about it, right? The two assumptions here at play. The products are the same. Or the people are the same. Which is easier to test from a data set?
People
People.
know this product because
Exactly.
we don't know who's using these.
Exactly right. We don't have data on the products in terms of their lab composition or things of that nature. So we need to explicitly challenge that assumption as an aim, right? So how will you frame it then? So, but you understand how we're going about developing our aims, right? The aims have to directly answer answer, provide the evidence we need to address this public health issue. So,
Yeah, that says. To mention that.
yeah, we have to mention it explicitly. But again, we don't have to do anything fancy. The assumption is the underlying assumption is that these people are the same. So the question is, are they the same people or not? Right. So the aim 2 could then be to compare exclusive users, but you cannot compare apples to oranges. Because if you have a group of people, if you have two groups, one group is some people who use e-cigarettes and those who don't use groups. So you can't compare two heterogeneous groups, right? So the bottom line of what we're saying is that when you're making such comparisons, you can only compare clean groups. What do you mean by clean groups?
Doesn't have the interest variable that we.
Okay. Okay, excellent. We have to separate these groups, right? So if we have two products here now, cigarettes on one hand and RYO cigarettes on the other hand, if you were going to create clean groups, what does that mean in practice? Operationally, what does that mean? How are you going to do that?
From the already existing data set.
Yeah, you have two columns in your data set,
Yeah.
cigarettes and RYO.
Testing people only do, only.
Overlap.
Okay, there can be an overlap, right? So that means that we have to create a new variable. So you see how the dog has to wag the tail. The aim has to drive how we think, and how we think has to drive the kind of variables we create from the data set. Does that make sense? It's not just that, oh, let's just create some random variables. No. We're creating variables intentionally to answer very specific questions, right? So here, for example, we've already identified some variables that we need to create. We've identified variables like, okay, we have to create any tobacco use with RYO, any tobacco use without RYO, combustible tobacco use with RYO, combustible use without RYO. So now that takes us to the second aim, which is to challenge that assumption that those individuals are the same. Simply, we're saying, are these two groups the same? Right? So when you're writing, don't start with the complex idea or complex framing. Write it simple. You guys are always trying to too sophisticated. Simple is good. Okay. So the question we're trying to ask is simple. Are these two groups the same? That's all we're trying to ask. Now, from that, you can now frame it to make it add more flesh to it. But let's stick with the basics for now, right? Because simple is good. And so this means that we would have to, for each aim of the study must have a methodology, its own methodology that drives it. Aim 1 here, so this is our aim 1, remember? And this is our aim 2. Again, these are very abridged versions. We're going to polish them later on, but again, this is high-level thinking for now. Are these two groups the same? So all these variables we're creating here, these are all to answer aim 1. Remember, aim 1 is simply saying, what is the prevalence of tobacco use with or without inclusion of RYO, right? So all of these variables we're creating here are driving aim 1. So this is aim 1 variables, and hence aim 1 methodology. Now, let's go to the second aim 2. So when you're writing your dissertations and your thesis, this is exactly kind of how one logical flow. Not just, like it should be logical reading your work from beginning to end. And when you make assumptions, you have to tell us why those assumptions were made. So that we can assess whether they make sense or not. Right. So defend your work. Don't be shy about making an assumption or stating it down. It's better to have an assumption that is explicitly stated than one that is assumed, that we have to now read your mind. No one can read your mind, right? We need to know what you were thinking when you did this work. So don't be afraid to put something down and stand by it. Okay? All right. So aim 2, we're going to create clean groups. So let's create clean groups. Now, again, we have two variables, right? var1 is current cigarette smoking VAR2 is RYO. How do you create clean groups now? Just operationally, nothing complicated. I just want, how do you take these two groups? Remember that here you have, each of them is dummy coded 0, 1. 0 is a non-user, 1 is a user, right? Please don't ever take a data set and just jump into analysis. I cannot emphasize that enough. You have to go through this thinking process. You have to put your thoughts on paper, right? Create a plan, an analysis plan. And then the analysis is the easy part, right? Got to think through the process. Yeah, that's where you're all philosophers, aren't you? Yeah, so act like one. So, all right. So how do we create a new variable that has clean groups based on these two variables? How would you go about that
I would
operationally?
Take the,
Mhm.
if you combine like the both 0 together
Okay.
and 1 together as a new variable.
Okay. Yeah. Any other thoughts? You look like you have something to say. Okay. So if we create unique combinations, how many unique combinations are we going to have from this? 4, exactly. Right? That's the same thing as creating strata. We talked about stratification
Yeah.
yesterday. Is that these concepts keep appearing everywhere? Stratification, right? So what will be the groups here? So what will be the
take
exclusive?
the
Mhm.
clean one would be 00.
Okay, so we'll have 00 here.
Then
So let's look at clean groups here. So we have 0. So let's say cigarettes is 0 and RYO is 0, right? That's group number 1. So this means in putting it in words, people, so neither product, right? They use neither product. Okay. What other group do we create from here?
1, cigarette 1
Okay.
and RYO 0.
Okay. So cigarette is what? 1, you said?
Yeah, and the RYO is like 0.
So what do you call this?
Product, but not wrong.
Sorry?
So like I would say cigarette product, but not like the wrong.
Use a cigarette, but not.
Okay.
Yeah.
Okay. What's another way of saying that?
Smoke at least 1.
I know you have to be very precise, right? Exclusive cigarette smokers.
Oh, okay.
Okay.
Yeah.
So you where you can try to be as precise as possible to your words. If you can say something with 3 words, don't use 10 words, right? So exclusive cigarette smokers. All right. Next. What do we have next?
Take 0 RYO 1, so exclusive rolling smokers.
Okay. Exclusive RYO smokers. Okay. And then what's next?
1
Okay. And what do you call that?
fourth product.
Okay. What's the common term we use for that? Dual users. Right. All right. So the idea is to create this variable and look at, are these individuals different, right? Again, remember that the research questions drive the methodology. The research question drove us to create this variable. This is a composite variable. We created it from 2 variables that were binary. Now we have created a variable with 4 categories, right? Now, in our regression analysis, what kind of regression will you use appropriately for a variable with this? How will you analyze this variable, for example, if you were to do a regression? Because then that affects the choice of analysis techniques you use, right? You don't say, oh geez, have been looking for where I'm going to do linear regression. And so no, that's not how it works, right? You don't impose the methods on a research. You find the most appropriate that fits the question. Exactly. Right. So what approaches are available for us to analyze this kind of data, for example? Yeah, what kind of logistic, for example? So here we've hit the snag, right? Because now we know what we want to do, but we've hit a major gap, which is gaps in knowledge, right? because now we're required to have, there's an assumption that we have a knowledge of all of this. And that's where, you know, a platform like Chi-Squares comes in, right? It's like, okay, just you create a variable and you say what you need to do in terms of the outcomes. And that's what we're going to go through, right? So that, but this part of the process cannot be replaced. I mean, no system, no technology, no AI can replace the ideation for you. This is your job as a researcher, right? And then the role of technology is now to help you with, okay, you don't have to memorize a million things, but you must know what you're doing. You must, you know. So now what we've done so far is to say, okay, we've defined our title, we've created our aims, we've identified our data set that we're going to use, we've justified why we're using a particular wave of a data. We've created variables, well, at least in theory, right? We've not actually created the variables yet, but in theory, we've gone over how we're going to create them and why we're going to create them that way, right? And now we want to create our table shells. Table shells are a way to visualize how your data will be analyzed, right? So we're going to create table shells. One of the things I did as, at CDC was to, help implement a system for review, concept proposal review. The problem we're trying to solve was people would submit work into clearance, and the clearance was supposed to be the first point where they were thinking about these manuscripts coherently, right? That's not a very good process. So what we did was say, well, you're going to have this form and fill this form and create table shells, and this is going to force you to think about your project clearly. So that it's not when the paper enters review that we're helping you think. No. You should have thought about the process very well. I always encourage students to create table shells because it forces you to think very lucidly about what is going to go into the analysis, right? So it's like you have everything except the actual data. So that's what we're doing now, right? We're creating the paper without the data. When we now bring the data, then that's the easy part, right? So our table shell. So we're going to start with table one. What's going to be our table one? Okay. The general flow of analysis is 1, 2, 3. So always remember that 1, 2, 3. Univariate, bivariate, multivariable. 1 variable, 2 variables, 3 variables, right? That's the general flow that analysis follows. And again, remember, if the methods and analysis are mirror images of each other, the two parts of paper are exact mirror images of each other. The introduction is a mirror image of what? What do you think? The introduction has to exactly mirror what part of the manuscript? Your introduction.
Introduction of the manuscript.
Yeah.
The background.
Background, introduction. Potato.
Mirror. Oh,
No.
mirror.
What part of a manuscript is the mirror, the opposite of the introduction?
Conclusion.
No,
Oh.
not necessarily.
I don't understand the question.
Okay. All right. Let's put it this way. The methods mirrors the what? The results. Excellent. So you know what mirrors there then. So you're just pretending that.
The introduction mirrors what?
Discussion.
Yes,
Exactly.
a discussion.
Exactly. So always remember that, right? The methods and the results. Here in the results, you're saying 1, 2, 3. We did univariate, we did bivariate, we did multivariable. The results will show here are the results of a univariate, here are the results of a bivariate, right? You don't want to be a magician. You don't want any appearance or disappearing tricks. Things start appearing the results that you had no methodology for them. That's not good, right? So these are some things we want to keep in mind that, okay, we want to make sure that there's coherence in the manuscript that it reads clearly. All right, so now we're going to have our table shells. It doesn't have to be perfect, but you should have some idea. Again, nobody expects you to fill it up a table shell, but it's just to put an idea. if you're writing a manuscript, it suffices to say that you should have an idea of how long the paper should be at least, right? How long do you want it to be? You can't say, well, I don't know. It's like, oh, really? You have no clue. I thought you were the author. Authorship, I mean, the word author is such a powerful word. It signifies that you have something important to say. That you're authoring these ideas, right? So at the very least, you should have an idea of what you're trying to communicate, right? So that's quite a solemn responsibility. All right. So now let's leave it at here. Now let's go now download the data set. Enough theory. Now let's now see how we can then create those variables and get that working. All right. So for those of you who don't have data sets, let's go to the NYTS data sets and then download. And so this is the link here. Let me drop the yes, please go ahead.
So whenever you do your in
Mhm.
variables and you do the dummy code, like 0, 1, but you were not including the code that for missing or I don't know, right?
We're going to go through that. Yeah.
No, like in the manuscript, because in my data there are like missing.
Yeah.
So should I include it in the manuscript ideation or no? This is just like
That's a good question. What do you think? So let's say you have you are trying to create a variable for current smoking, right? And you have people that said, I smoke. Another guy says, I don't smoke. Somebody says, I don't know if I smoke or not. Right?
yeah.
That's quite interesting, right? You imagine that if somebody smokes, they'll know whether they smoked or not. But you get that all the time. And somebody else says, don't want to answer. Or, now, remember you want to code these variables as 0 and 1. What will you code? I smoke.
1,
Okay. What will you code? I don't smoke.
0,
What will you code? I don't know.
7.
Okay, but you want to code it as binary, 0 or 1. So where will I don't know fall?
Very good question.
Where it falls between,
Will
should
it?
I add it to the smoke or I don't smoke?
I'm asking you.
I
Yeah,
wouldn't include it
okay, why?
because it's not gonna give me any insight in what I'm looking.
So what will be the value? So remember you had this
Double
variable.
zero.
No, remember this individuals were coded as 1, 2, 7 here. Let's say this was a value of 7, and let's say 9. Those were the values in the data set. You want to create at the end of the day a variable that is binary, 0 or 1. You have correctly said that you're going to code I smoke as 1 and I don't smoke as 0. But you still have values of 7 and 9. What my question to you is, how are you going to code those ones?
And these,
Okay, you can set them to missing. Why?
We need the variable to be binary.
Okay.
And also they're gonna be noisy, so they're not gonna add anything to my analysis.
What's the danger of saying, okay, I don't know, I'm coding it as 0?
It's really small.
Yeah, like maybe overestimate, underestimate.
Okay.
Therefore,
So what kind of bias is that? You guys need to speak like epidemiologists. What kind of bias would that create?
classification?
Exactly. That creates misclassification bias, right?
Yeah.
Because you are now your assumptions, you're now feeding your assumptions into the data. You are saying, oh, well, the guy says I don't know, so most likely, or I don't want to answer. So you are saying, oh, well, I'm going to assume that people would say that don't.
They smoke.
They smoke, right? Yeah. But now, right, what if it's a question like this? What if it's a question about not smoking, but about, let's say, are you aware that smoking causes cancer? The person says yes, says no. They say, let's change this I don't know to not sure, just to make it consistent. I'm not sure. So Are you aware that smoking causes cancer? Let's say lung cancer specifically, right? Yes, no, not sure. Not sure. Right. Don't want to answer. My question now is there a difference between the not sure in the first one and not sure in the second one?
Definitely, because it's knowledge now.
Exactly. So some constructs as such that not sure now is a very, very important response that you can't that it makes no sense to put it as missing.
Gives us an idea about like the amount of people who actually have no idea. Like,
Exactly. So the point we're just trying to say is that context is king. Don't say, oh, well, whenever you have not sure, set it to missing. No, that's not what we're saying. What we're saying is that context is king. Right? You have to pay attention to the context of the study. So things about knowledge, awareness. Have you heard of this? No, not sure. Those are important, right? But then when it comes to behavioral issues, again, that's a different context entirely. So that's the moral of a story. Okay. All right. Now let's look at the data sets. Mhm.
So my follow-up question, I think some of the things that they would be worried about is, so do you then take away, like, for example, don't want to answer, do you then discard them? Or do you then put them as missing? Because sometimes, yes, it depends on the amount of not sure that is missing in your data set. Because I know sometimes from a biostatistics point of view, they always tell you that sometimes no response is
The
the
response.
response. Yeah, you have to also provide analysis of your non-response, and put all of that into context and analyze that. So the question is that they just limit it to providing NAs in the descriptive, and then when they're doing more of a bivariate or multivariable analysis, exclude that. So I never get a full answer to
Yeah.
that question. I don't know what do you do in practice?
So in practice, all the NAs will always be indeterminate responses will always be set to missing
Okay.
because you can never be sure whether it could fall either way, right? It could either be that the not sure, I don't want to answer, could be that the individual is saying yes, or it could either say no, right? You can't never sure. Yeah. So, but the moment our assumptions come in, we say, oh well, this person must be doing something bad. This is why they said I don't want to answer. It's like, oh, like especially when it comes to sensitive issues like, oh, has the doctor ever told you you have HIV? Yes, no, I don't want to answer. It's like, this person has HIV. Like, like, how do you know? That is very dangerous, right? They could just say, I don't want to answer. Like, it could come from the perspective of, I don't want to share my health status either way, whether it's, but most of the time we are always, inclined to judge that if he said no, then this person is very suspicious. So in as much as you cannot tell, it's safer to just put as missing. And if you really want to include it that way, you would have to really, really check whether there's a systematic difference between those two groups, right? So that at least it's defensible. So general recommendation is don't classify it either way. But if you must classify it, you would have to do some comparison of those two groups to show that they're exchangeable. So that at least that you have some answers to why that was done.
Some sort of sensitivity
Mhm.
analysis.
Yeah.
If they say if you include these people this way, okay.
Or these two groups, how do they compare on age, on gender, on other characteristics? So that you could say, well, they look alike in all regards. So maybe they're the same group. But there's just a lot of assumptions. It's very lot of assumptions.
That's stronger assumption.
That's a heroic assumption. So all right. So let's download our data set now. So NYTS, when you try to download the data set, please always look at the code book. The code book is very important. What's another name for the code book? What other word do we use to describe a code book? The data dictionary.
Yeah.
Right? It tells you everything about the data set. So So we're using the 2017 wave for reasons we just explained. So here you have different formats, Microsoft Access. Always try and download the version that is easiest, that you are most familiar with. You don't get extra points for saying, well, I actually don't know how to use SAS, but I want to show that I'm a very solid researcher, so I'm going to use SAS. Well, just download the one you're most familiar with. This is why we try to provide data sets in different formats, so that you are getting the exact same thing, whether you download Access or whichever, right? So we're going to use, again, simplicity. Let's use the Microsoft Excel. So download the data set. It typically comes zipped, and the report is typically separate. So here, this contains the data set and codebook. But as you can see, the report is different, the methodology report, right? Why would you need a methodology report?
To show you how you could use the data, like for weighting. Okay.
Exactly.
Yeah.
And also the methods. If you want to write the methods section of your study, you need a methodology report. So we're going to download that as well, because we need that too. All right. So let's go ahead and extract our data set. So here we have our download data set. It comes zipped. Why do we zip files, by the way?
For smaller size.
Yes, exactly. For storage, so that it's compressed, all right? So you have to unzip it to extract the content. All right, so to extract it, you simply click on Extract All, and then you choose where you want to save the file, right? So click on Extract All, and then you would have to select where you want. You can select on your desktop, or you can select wherever the destination is. So I'm going to browse the destination, for example, here, desktop, and create, that's a new folder. We call this HSDM. Select the folder, and I'll extract. So you can see the file path. I'm going to extract now. So now it's in this, see the file path. It's in my HSTM folder now. Are you able to do that?
Yeah, MacBook is a different way. Like you just
Okay.
click it twice, it will
Okay.
decompress.
Okay. All right. So good. So we're all set. Okay, good. All right. So this is the data set. This is the code book. Always open the, please don't attempt to record the data set without opening the code book. Unless you are a magician, like you automatically know what the codes. Code book. What is a code, by the way? What's a code book? What is a code?
How the variable is like called name during the
Okay.
report.
So give me an example.
It's like
So
what was the question they asked for that specific and how they labeled it and everything.
so this question we're talking about here, right? What are the codes?
1279.
Exactly. That's what we mean by codes.
Yeah.
So when you say you are recoding, what are you trying to do? You're changing the codes, which could either be collapse them together, or it can still be the same number of items, but the codes simply change. I might change it from 1279 to 1299911. It's still a recode because the codes have changed. Or it could be collapsing it so that instead of having 4 groups, I have 2, 0 and 1. Again, codes have still changed. So we need to understand these things from the simplest level possible. So that's why you need the code book, because the code book will tell you what each of those codes mean. If a variable sex has values of male and female, what are the codes?
Is it 01 or 12? You know,
No, the codes could also be, in this case, male and female. In this case, they're just string, right? So code simply means what is the values captured in the data, for better or for worse, whether they are string, numeric, right? All right. So we have So let's take track of what we've achieved so far. We have our code book, which is this. We have our data set. We have our methodology report, which is this one. And then now we can now import our data set and start our recording. Any questions at this point? Is it time for a coffee break or please? I tend not to look at the time. So if we're time for a coffee.
Break for another 30 minutes.
Okay, already.
Right?
All right. So now let's now read the data set into the Chi-Squares platform and start getting our analysis ready. What's the difference between data management and data analysis?
Then also analyzing management, how you store, keep everything in files, like for appendix or like if they ask.
Yeah, the point I'm trying to make is that data management is all the processes you do before. The easiest part of analysis is generating the tables, running the analysis and getting your tables, and that's the easiest part. So please don't obsess about, oh, what are the final results? You have to obsess about all the processes leading up to that, right? That is what takes time. And that is what you are getting a degree for, right? That you have put your thoughts and that you have spent time going through all of those things. Anybody can generate results in minutes, right? That's not the hope that, obviously we're not spending the whole day today just talking about generating results. It's about how do you think through the process? How do you think to challenge your assumptions? And all of that, right? That's why we're here. So don't obsess over the results. That's the moral of the story. All right, let's get over. Let me keep this our documentation open. Let me just open a new instance of the Chi-Squares platform, and we're going to now head over to the analysis and start a new project. And we're going to call this project our RYO analysis. So you can enter a project description if you want to. If you don't want to, you can leave it. I really don't care about that, so I'm going to skip that part. And now we're going to upload our data set. So oops, what was it there? Okay, so our data set has been imported. If you have a data set with sketchy elements like questionable names, the platform will flag those and you have to correct them before you proceed. There are two ways to handling bad data, right, or like bad variable names. Either we simply don't accept it or we accept it and tell you to correct them. So we do the latter. So, so if you have a data set that has been flagged as bad data, then you have to make the corrections that are needed. In this case, all is well. So when you import your data set, you want to make sure that things are fine, that things are how you expect them to be, right? In clinical practice, it was the first step to examining the patient. All clinicians, what do you do first? IPPA, right? Do you auscultate? Do you percuss? What's the first? You inspect first, right?
Ask them what brings them in first. Then
okay, no, I'm saying examination. No, no, not
evaluate.
evaluate. Okay, yeah. So after after you've asked them and spoken, now it's time to examine now, right? You inspect first, right? You don't go and grab the data first or touch them first, right? You inspect. The same thing applies with data, right? You have to inspect your data first.
Eyeball it.
Exactly. Don't be in such a rush. Like, why are you all guys always rushing? Don't be in a rush to go and get results. Inspect the data, see what it looks like. Does that align with what you expect? Of course, before you bring a data set, you already know what to expect, right? You have, on some level, you know what to expect. At the minimum, you have an idea of how many people should be in the data sets, right? Don't just imagine that technology will always work seamlessly. Every technology fails. You can import a data set into any software and it may not read it well. And you are there with maybe you read all the 1,000 rows as one single row. They did not throw any error, right? But you are there thinking, oh yeah, my data set is imported. Did you look at the number of, did you look at the sample size? That's dangerous. So when you import a data set, just do some basic due diligence. So here, for example, 373 columns, 17,872 rows, right? That's what I expect, right? Okay. I may not know the actual sample size, but it kind of sounds right. That's that's the level I would expect for a survey like NYTS. So look around and make sure that the things you're seeing align with what you expect to see in the data set. And then, look at some variables around. Are the variables, the missing values, are they what you expect them to be? You may not necessarily know all of the details about the data set, in mind, but at least, browse through the data set and make sure. It would be very bizarre, for example, if you saw a fixed number of missing values for every single variable. That would be bizarre, right? That would flag that something is not right. So common errors in import could be, again, like I said, fail to import. There's no row, no rows at all. Everything is one row, one long, row. Has anyone ever experienced that before? Have you experienced any of such errors before?
Yes, when I downloaded the NIST first, before I run the code to decompress it, and it showed me it's just one long.
Exactly. So see, if you don't inspect the data, you won't see that, right? So you have to, and then visualize the data, see how it looks like, And so those are some of the easy things you want to look at first before you jump into analysis. Anyway, now let's go on to our
Flag for renaming. Is
exactly.
that what-
Oh, exactly. So now you have a flag there because like some variables may not be aligned
just
correctly.
Accept.
So
Exactly,
have we all been able to upload our data? Have we been able to upload the data?
I uploaded the CSV to what you created.
Up to the
Yeah.
platform, okay.
So what's the next step now for us? You've uploaded data. What's the next step?
Visualize.
Visualize. Okay. All right.
Define what's our outcome and exposure.
Mhm.
Like
So in this case, we have to create our variables, right? We have to create variables for all those tobacco products we had in mind. All right. So this is why it helps for you to write everything out clearly. All right. So let's recode the variables of interest. So to recode, you come to data processing. So let's give a quick overview of how the platform is structured. Data processing has to do with everything that relates to management of data, cleaning data, processing data, right? And you have it in 3 buckets here. Basic variable operations, which are operations at the level of the variable, like rename a variable, respecify, and clone or cross-tabulate. Then you have transformations, which is changing the nature of a variable. And then you have actions at the level of a data set. So actions at the level of a variable or actions at the level of a data set. So that's how it's structured, just for ease of reference and access. So any of these actions you are doing here for actions at the level of variables, you can either access them from here, data processing, or you can just go to the variable and access it from more options under the variable. So you see that under here, I can see.
Oh, can you hide the,
Oh, okay, sure.
there's a button where,
Oh, really? Let's see.
no, no, not there. Okay, no, even the,
this one.
okay, I know, okay.
Oh, nice. I didn't know that feature existed.
You're very welcome.
Thank you. All righty, awesome. All right, so for all of it, so again, remember there are actions at the level of the variables and actions at the level of the data sets. And we said that for all of those things that are accessible at the level of a variable, you can access them from either here, data processing. Like for example, you can see recode is accessible from here, or you can access it from the level of the variable itself under more actions, and you can now choose recode. So it depends on where you want, whatever is closest to you. So this is the code book for the Chi-Square platform. It's called a code book because it contains all the codes. So it tells you exactly. It tells you the number of unique values each variable has and the variable type. There are about 5 types of variables on the Chi-Square platform. You have discrete variables. We have, what's a discrete variable, by the way? What does discrete mean?
Talked about this.
Like count.
Okay. Every count is a blank, but not every blank is a blank.
Every count is discrete, but not every discrete is count.
Exactly. Why?
Because we could have because
Okay. Count can only assume what kind of values?
integer.
Okay. Excellent. You can now have negative counts, right? But can you have discrete values that are negative? Yes, you can. So discrete values are they refers to any quantity that takes in very specific values, right? Counts are always whole numbers. But remember, discrete values means in the pure technical sense, count or values that take on the very specific values. Think of shoe size. Shoe size comes in what? 5, 10, but also what? 5.5. See? Is it so it's not count, it's discrete because it comes in very specific values. But in this case, in this very special edge case, it happens to take on fractions. That is still discrete because it can only take on very specific values. So you can't exactly come and say, oh, my shoe size is, I'm just going to make up 5 and 5.244. It's like, oh, that does not exist. Right. You're just making up stuff now. Right. You can't make up stuff with discrete, it takes on very fixed values. So every count value is discrete, but not every discrete is count. Does that make sense? So so discrete values, so that's why on the class every type of variable has a designation on how it looks. So you can look at the discrete values have 1, 2, 3 as their icon. So wherever a variable appears, you can see its type, its icon, and that's just for ease of referencing. The next type of variable you have is and then the visualization of, before I leave those ones, the visualization of a discrete variable can take in, you can display it as it's the individual discrete values, or you can choose to change it to, for example, like the mean of those values, right? Depending on what you want. So that acknowledges that property of discrete values accordingly. So again, so discrete values, that's one type of variable on the platform. Then you have indeterminate. So indeterminate variables are those that have what? What do you see here?
One unique value.
One unique value, right? For a variable to be a variable, it must what?
Has more.
Yeah, I want someone to rhyme with me. For a variable to be a variable, it must,
Valid.
excellent, it must vary. Right? If it has to vary. So vary means that it must have what?
More than one.
More than one unique value. You can so a variable that only has one unique value, can you analyze it truly?
No.
No. It's useless for the sake of analysis. So why allow the person bring a variable that will only throw an the Chi-Square platform is built on the premise that why should we allow you to make this mistake when we know that it's going to throw an error? It's like, no, we have to classify things in a way that prevents error. So we have to protect you from yourself. It's based on an assumption of no knowledge that this person using it has no idea what they're doing. And the platform must then protect them. Right. So indeterminate, that's why you have a question mark, because we don't know. It could have been discrete. For example, if the value is 1, maybe if you had 1 and 2, it could have been discrete. It could have been cut. We don't know what it could have been. So since we don't know, we call it what? Indeterminate. Does that make sense? The next type of variable on the platform
Because I
is
was thinking of the stratum variable for weighting.
okay.
That would be indeterminate.
Okay.
Because it's just one weight.
Okay. So in this case, is the values of a variable now, whether the value, if it has only one unique value. If, for example, gender has only male, you can't analyze it because it doesn't vary. So in that case, it's classified as indeterminate. The next type of variable you have is continuous. So let me show you. So this is how continuous variables are designated on the platform as a scatter, right? And so you have variables that have floats. Do you know what floats are? Decimals.
Yeah.
Right? If you have a decimal, it's a float. Or operationally, how the platform makes a determination is we take on a value that is a proxy for infinity. So let's say 1,000 unique values. Variables that are numeric and that exceed that cutoff are classified as continuous, or those with floats are continuous. Those below that cutoff are classified as discrete. The same thing applies to string variables and categorical. So let's look at string. So string, what do you mean by string variables? Do we know what that is? But when you hear of string, what comes to your mind? The thread.
Yeah.
Yeah, that's what comes to your mind. And that's exactly what it is. Think of just a sentence that keeps going on and on, right? That's like a thread of sentences, a thread of words. That's a string. So most times the first thing that comes to your mind is actually correct. You just need to now visualize it in the statistical context, right? So think of, if we collected all your street addresses or what kind of variable would that be? Would that be categorical? Would that be string? What will it be? String. What if we collected everybody's name in this class? String. So the question is, what's the difference between string and categorical? What makes one string? What makes one categorical?
Categorical, many people could be in that category. But string, it's very unique.
If we ask people to write down the names of their country, got a bunch of people, right? Educated, non-educated, a bunch of everybody, right? I ask them, just handwrite the name of your country. What would that likely be? Will that be categorical or will that be string? Most likely would.
Either the string is.
Oh, they have
Because people have misspelling.
Is that?
Spelling and font size
Mhm.
or character. Yeah, capital.
Yeah.
Exactly. So if you got a bunch of people with little education and ask them to write down the name of their country, you're going to have a string variable. Because, like you said, people are going to misspell things. So what matters is the degree to which you have recurrency in the options. For categorical, the options recur. For string, so any variable could have been categorical, but it could also be string, right? Depending on how it appears. It's all about how you define that, in the algorithm, right? Male and female is clearly that one, everybody will agree it's categorical because that particular value appears over and over and over for a lot of people. So you can think of them as groups. The group that we're calling male versus the group we're calling female, right? With string, it's not that same way. You might just have almost each value is like unique, and you have a much less degree of recurrence or repeatability of each value. So that's how we have also implemented it here. We have a threshold for infinity. Anything above that threshold is string. Anything below that threshold is categorical. But we could make a mistake, right? We could misclassify, and that's why you have the option to respecify. Because obviously context is king. But the platform says statistically, well, this is more likely than not that it's string, or this is more likely than not that it's continuous. And then you have, so this is string. Then the way we visualize string variables is also different. On the platform here, we use, word clouds to visualize variables that are string. So in this case, this variable, for example, could have been numeric, right? Because you guys, as you can see, it's a bunch of numbers. But the way it was captured as string. You have leading zeros and was encoded as string. So the whole point of respecifying is to say, well, let us respecify this as a number, not as a string. And the platform allows you to do all of those things. Yes, yeah.
Can it be a character? Is that an option within the platform to do something? Because IDs are usually in the traditional R sense, you put them to character.
Yeah. So R's character is our string in this
Okay.
case here. Yeah. So
Okay.
yeah. All right. So those are the classification, and then we have date. So the classification of variables on the Chi-Square platform are string, categorical, discrete, continuous, and dates, right? So those are, and then you can specify as the need be. You have the number of missing values is displayed clearly. The philosophy is that there are some things that are so basic that you shouldn't have to go and start jumping through hoops to get that information. Like missing values, that should be something on your fingertips at all times. There's no need for you to go and say, oh, I need to go and write a line of code to get number of missing values. It should be obviously right there in your face at every single time. The same thing with the number of unique values, right? It's such a key information that there's no point having to go and require the user to start jumping through hoops to get that information. Then notes and tags allow you to tag variables. When you add the tag, you are saying, for example, this variable is, student's ID, whatever it might be, right? And that's helpful because when you, for example, want to get suggestions, let me run an example. If you want to get an idea for what kind of analysis you should perform on this data set, the platform has a research idea suggester, right? That research suggester takes your variables and uses AI to say, well, here are some suggestions we have. Now, the variable names could be meaningless. You could have a bunch of variable names that are completely meaningless in of themselves. That's where the tags come in. The platform could take the tags from the data set and say, well, here is context for what these things mean. And so it just gives you a better suggestion than just V1, V2, V3, V4, like what does all of these things mean? So in this case, so you see, how do the variations in numerical identifiers correlate with, the numerical identifiers in this case is not meaningful so much, but the platform has no context for what it means. It's just an automation. So it doesn't, so most of those things you will have better ideas or better suggestions if you added context. And that's the very role of you adding tags. That's what the tags do, right? For things that involve suggestions, the platform takes a variable name, and then if there are any tags present, it takes those tags or notes and allows you to have a much richer suggestion that makes sense operationally. Are we at time?
We can go, maybe next 6 minutes, or we can go now and come back. Should we go 5 minutes? And then come back?
Okay.
Yeah. So, yeah. So what I also realized is that when I uploaded my data, because it had some unacceptable
Characters.
things, it said, oh, we won't go forward. We need to go in and rename it, right?
Yeah.
Before, but I'll give you renaming options.
Yeah.
Once you click on that option, did you click on did you do that? Did it rename for you? Yeah.
We will not go
Yeah.
ahead with another.
So there's a link that should come up here. Say
Click here to rename it.
yes. It will give you suggestions of the renaming.
So this should mean this.
Hello. Hey guys, we are on 5 minutes break, so we'll come back shortly.
Now we have it.
All right. We are now beginning our session now. Let's minimize this again. All right, any questions so far? Are we all good? All right. So now we're going to go to the next phase, which is to create the variables we need. There are some basic rules we want to adhere to. Rule number 1, do not ever delete, replace an original variable. That's a really bad idea. Who can imagine why is that a bad idea? Replacing, deleting a variable that an original variable in your data set. What are the things that could happen that makes it such a bad idea? Yeah,
How the code book is not running.
yeah. You might need to go back to the original variable, right? So what happens now that you've already erased it or modified it?
If it's not there, you might forget what was it.
Exactly. So always create a copy or create an when you're recording, create a new variable. All right, let's now create these new variables, this first part. So on the ChaiSquares platform, certain procedures are require the variables to be in binary form, 0 and 1. So like prevalence estimates, they are calculated on variables that must be binary coded as 0 and 1. So let's recode all these variables that we need into 0 and 1. So let's do that now. So we'll come to data processing. We'll come to recode. Custom recode, you can go to custom or binary. Custom recode simply means you can do whatever you want. Binary means it's specifically, let me show you how they look differently. So with binary recode, when you select a variable, let's say current cigarette. So select that variable. This is what the binary recode looks like. It gives you, binary means 2. So it gives you 2 boxes and says drag the item that should go into 0 here and drag what should go into 1 here. Binary typically means 0 means absence and 1 means presence. So that's so you just drag. So here I can just drag 2 here and 1 here. Now, how do I know what 2 and 1 means? How am I supposed to know what 2 means? From the code book. So please always read the code book first. All right. So so we'll go to the code book. The variable we're looking at was F. Let me look for it. So this is the code book. The code book here tells me that 1 means yes and 2 means no. That's how I know that 2 means no. Please never assume, never ever ever assume that assumptions and research don't go together, please, right? Always go and consult the single source of truth, right? So in this case, the single source of truth is the code book. So you must consult it at all times. So 2 means no, which is 0. So I can drag this here. But remember that this is not the only variable I want to record. I also have a lot of variables I want to record. So in that case, I can just click this button that says enable batch recode. Click that button. And now I can select all the other variables that I need to recode. For example, biddies and dissolvables and snooze and current pipes and roll your own cigarettes and hookah and current electronic cigarettes and current chewing tobacco and cigars. This is all bulk. Obviously, I don't want to be doing the record for one of them individually. So the bulk record simply says, whatever you did for that one, do it for all of the rest. And maybe I want to do for the, the ever use. Maybe I want EBDs and dissolvables and snooze and pipe.
Sorry,
Yeah.
I just have a question.
Yeah.
Okay, do you guys prefer it zoomed out or just zoomed back? Which one? I feel like the zoom in makes me forget where the thing is.
Oh, the context.
Yeah.
You lose the context window.
Yeah.
Okay.
So zoom it out, just kind of where
Yeah.
everything is.
I
And then
understand you completely.
Spatial awareness.
Exactly. Spatial awareness.
Yeah.
And this will only show me the one that's binary. Like
Exactly.
there are other that has like yes and no missing. Would not show me. I have to go manually to the.
Yeah, because you remember you were saying that record, do whatever you did to the first guy to all the other guys. Well, the other guys have to be like the first guy for that to be even logical. If you're saying record, strongly agree, somewhat agree, whatever, to these categories, well, all of them, all the other ones must be in the exact same format for it to make sense. Huh?
Recording is not-
No, we're just explaining it. What
Oh,
we're doing.
is it in the video? Is it's not recorded?
Oh. Did we stop recording? No, but we didn't stop
Like-
recording. Let me check. Okay, it's recording. Pause or stop. So that means it's recording. Oh, sorry, I thought you said it's not recording. And I'm like, yeah, we've not clicked it yet. Yeah. All right. So let's record. So we've done the recording we've selected all the variables we want. Let's just select ever use of cigarettes and ever use of roll your own too, since that's part of our research question. So far, does everybody follow what we're doing so far? Okay, so we are done selecting. So this is the variable we want to record originally, current cigarettes. So what we're saying is that, well, take whatever action you do to this guy and apply it to all of these other guys. And that is purely for efficiency reasons. They're all coded exactly the same. And so we don't want to be doing the same thing, in all cases. So our code book tells us that 2 is 0. So we're going to drag 2 to 0, right? And then we're going to drag 1 to 1, right? And we are done with our record. So that's that.
Do you, in a epidemiological study in general for male female, do you like always do like male 0, female 1, or doesn't matter?
It's a nominal variable, doesn't matter. Whatever you want. Yes, go ahead.
I'm going to combine them with both the observations with the new variable.
We're going to do that now shortly. Right now, we're just looking at transformation of single variables. We had those variables and we need to create them so that they're all 0 or 1. That's what we just did now. We move.
Like for me, one of the variable is mental health days, which is given 1 to 30 days. But I want to split into 2, less than 14 days, more than 14 days 1, less than 14 days 0.
Okay.
So I have to give this information somewhere.
Let me show you how you do that. Let me just finish this now, okay? I'll show you your use case now. So the platform automatically gives the variable names as _R for batch recode. So if you want to keep them, there's no reason why you should manually start changing the names unless you just like suffering, right? So I'm just going to accept the names as they are and proceed with my work. And so all the variables have now been recoded. So it's as simple as that. So you see all of them are now binary, 0 or 1. Now, the question you asked was, you have a variable that is continuous and you want to split it. So in that case, let me look for a variable just so we're on the same page. So let's just pretend.
Try to practice it with that. The one you have now.
So in here, discrete, that's fine. You can also select that. Now so click on record.
That's the last sample page, right?
No.
Okay. Good. That three button. No, you're clicking on the wrong one. This one.
I love how when we change recording, it still keeps the original one, just to add the new,
Oh, definitely, yeah.
just in case if
Yeah.
you wanna.
Yeah, so this are just designs. This was designed by Plimnology. So what do you
Yeah.
expect?
So you do.
My bad, sorry.
So how you showing, visualize, it's not showing, it transform, is it transform?
No,
You have to scroll down.
Scroll down.
Scroll down. So you should see something like that on the screen.
Record, what do you press again? Visualize, okay, she's seeing it, yes.
So click on record.
Yeah, she's seeing that.
Okay, then you just click where in this case, for example, if I want to split it at this value, just click where you want to split it and confirm the number you want to split at. And confirm.
Click on it first and then you change it to continue. Right. Okay, confirm. Proceed.
So you confirm, is that what you want? Does it the group's assignment then you proceed, you assign a name and you proceed.
Right.
So you type a name of a new variable like new weight or whatever the new variable name is.
Mental displacement.
Okay.
I can do.
Okay.
So how easy is that? Pretty easy, right? And so again, the platform is designed for an 8-year-old child that anyone should be able to do these
So
things.
this is for continuous, discrete, and
Yeah, continuous and discrete,
category where we have, like for the income, for the insurance, they have multiple divisions.
So you just drag and drop.
Yeah.
Oh, we're going to do that right now.
That is different from this one.
Yeah.
The reason why you did this is because these are, this is discrete or continuous. So you
Exactly.
have this format. But the one that are like, multiple categories, you want to combine them into small categories, you can, drag and drop.
Exactly, yeah. And the platform automatically detects that. So you have the option displayed based on the type of variable you have.
I don't want to stop it. Like we have this, like what, in a month, we have 30 days. So it was less than 14 and more than 14. Now here they're showing 14 to 99. But we are just checking for when we asking the question from the participant, we are checking last month.
So that means that your data set has a value called 99. It's only seeing what's in your data set. Right? So you might want to replace that value as missing. So if it's showing 99, that means that you have a 99 in your data set.
Oh, that is maybe the missing value or something.
Exactly. So those are part of the things that you have to clean first before you
So instead of doing this, what you then do is that you can close it out, right? And then can you clean it from here?
Yeah.
Now,
Is there a way to
Reset the data?
exactly, yeah, you can reset it. But for example, you can if it's this procedure, I can just reset progress. Oh, okay. Oh, okay. Well, you can delete the variable so you can upload a new data set.
If I go back.
It's deleted, because when I deleted it, it didn't.
So if you want to change that 99 to missing, what do we do?
So those are days, right? 0 to 30 days or what?
There is 99 and 8.
So So if the variable appears as discrete like this, click this button here and say, if it's, let's see here, if your variable is, it's, let's reset progress here. If your variable, in this case, this is a continuous variable, but if yours is, you should have an option that says treat as categorical. Do you have that?
Yes. It's good. Keep as categorical. Yes, there is a.
And then you can now do whatever. You can now select the ones you want and merge them and specifically change the 99 to missing under the more actions.
Go off. No. Go off. There are more categories here. So this 77, 88, and 99, right? These are the ones that you have to drag as missing. So you can drag all of them together. And you put it up.
So you can change if you don't want the sound effects, you can put them you can put them off.
So you can say edit label, right?
Edit label.
And
So-
just edit that label to make it, I call it missing.
So you can under actions just say treat as missing.
Okay. Okay, treat as missing. Okay. Okay.
I have questions.
So now, can you now drag,
Sorry,
you now drag the rest into,
Whatever you want.
Okay.
If you want to drag to missing, you drag to missing.
Okay.
If you want to collapse them together, you collapse them.
These specific only HPV shot. Yes, no, don't know, refuse. So I put these, combine them, 77, right?
Yeah, you can put them to missing, yes, yeah.
Okay.
So select what you bought in,
And then you can assign
Yeah,
as
and that's
missing
a-
under more actions.
manage selected category,
Edit label,
No, treat category as
See
missing.
what you bought in mixing.
okay. And one, yes, I put it as one.
And you don't even have to do all of that work. If you don't want to treat it, just leave it there. The platform will treat as missing.
You do, what's in it? Is it
Oh, okay, I see.
It's like it was just the extra work for nothing.
14 to
Okay.
30 or
Less, greater than 14.
Okay.
okay, greater than 14. Okay, so 14 and below should be included now. It is greater than 14. So
Are we all making progress? Are you guys all set on this side of the world? Okay. Baby, you seem to become an expert, or you seem
It's
the way you're
really
moving.
fun.
You are really moving very smoothly over everything. Okay,
One last question.
Go. Mhm,
Any Medicaid, other insurance,
mhm.
uninsured. And this is they define other.
Then you make
Should-
the other one.
There, yeah.
Should I leave it as is?
Yeah, you can leave it as is, you know,
Yeah,
just
just keep
Now
the
merge them
and
together.
missing, like this is like missing for,
yeah, you should look
but it
at,
doesn't have value missing.
well, you check the data set, which when you check, you're going to see whether it has missing.
Saying that the categories that you didn't merge will stay as it is until you merge them. So the ones that you didn't, this one that will change the name is the merging of all those 14. The ones that you didn't merge automatically,
One,
not
five,
okay.
automatically just be merged.
Yeah,
Okay.
So you have
So,
to merge.
and that's
this
why
one.
they
You have to merge this much as well
different number.
from,
okay.
let's see, you selected it, you know, selected it. And this one selected. Please.
Are you sure that's the same variable you're looking at?
Mental health is, let me call this up.
So is that a variable you're looking at?
Yeah, I'll call it FMD one. These are the people that have frequent mental health days, right? That have mental distress.
Yeah, this is like,
These are above 14,
insurance.
so call it one,
what
right?
does it mean imputed?
And
Oh, imputed
And
means
then,
that there's a
and I'll
lot
call
of
it
guessing.
people
So there's a
FMD.
that means are you sure are you looking at the imputed variable or the actual variable there?
This is says imputed.
Yeah, imputed is not the raw data.
FMD.
We took the raw data and we made some guesses to it.
So which one should I use?
It's usually the original variable.
This is people missing.
The original?
Yeah, yeah.
FMD.
So the one you're looking at now, is that imputed or the real variable?
It says imputed.
No, the one you were looking at right now. So the Chi-Square platform.
Computed.
Okay.
FMD cards. Then we put it. So call it F.
Well, I can see
FMD.
Mm.
Or can we call it FMD category? FMD.
models. There is only imputed.
Okay, then that's fine. Then that's what you have to do. You have no choice then. But you understand the concept of imputation, right? It means that they were missing values, and the question was, how do we deal with these missing values? So you do multiple imputation. What it does is that it takes that data set and runs regression, and each time it makes a guess, and it takes on that. So it creates multiple data sets with predictions of what each possible value could do, and then it's like an average of all those guesses.
Okay.
And it says, okay, this is this guy is missing. Now you have to be very clear that multiple imputation requires very heroic assumptions. That assumes that data are missing at random.
Okay.
If that assumption is violated, then you are in trouble. So tread with caution. But if that's the only variable that you have, then that's what you have to use. How are you doing over here? You're good? Okay, that's good. Okay.
Not sure if it will work or not. I'm just-
Okay, well,
now, Ashu, you got,
Yeah.
okay.
are we all following?
Okay.
Hanu, you good?
Yes, I'm keeping my variables and
Okay,
I did the code.
okay.
All right, good. So now I'm going to create my variable here for, yes, there's a hand raised online.
Please, hello.
Yes.
I have a question, please. This, I want to know, this meeting is not French version, version.
Oh, okay.
This meeting.
You're talking about the platform, the version of the platform that you're using is not a French version. There should be a way you can, let me see, hold on a minute. You can change your
Please?
language to French.
Yes.
Check.
What can I put it?
Check the button at the top where you have languages. See, you have an American flag at the very top. That's the language. We have the language there. You can select to French and it will change the language, but it doesn't change every single thing. It changes some of the major things, but of course your data set will not miraculously change to French, right? It will still contain the values that it came in. So that only affects the other metadata around the platform. But you still have to contend with the data set itself and whatever it came with. But yeah, that's how you can change the language from up there to the preferred language.
I no see it.
Okay, maybe you're using a small mobile screen.
Right. Yes.
Yeah, Lungile, please, can you, Lungile, I may need you to help, provide some guidance so that we don't derail the session currently. And we can also provide, after the session, you can also write an email to us so that we can provide, maybe some more custom support to you.
Can do is that bring our tool to one break. So those that have
Exactly,
questions- so that
exactly.
have questions can come.
Exactly. And in exactly about, in about, 45 minutes, we will have, I'll be able to address your concerns more fully because we're going to take a break at that point. So people who have that kind of technical questions can wait, and we'll address those questions then. Thank you. All right. All right. So now let's create our variables for any tobacco use. So let's see how we can go about creating them. So to create that, that's a composite variable we're trying to create. So we'll come to data processing, create composite variable using conditions. What's the difference between these two options here? Create composite variable using conditions and create composite variable using unique combinations. What's the difference?
Condition, it's like when we combination, we could provide the four combination that we decide.
Yeah.
Condition is like with this.
And please, can we mute? Lungile, can you mute everyone, please? Okay, go ahead. Yes.
Yeah, that's
Okay. So unique combinations. What scenario did you discuss today that will require unique combinations?
exclusive.
Exactly.
That one or both
Exactly.
dual users.
It's completely meaningless for somebody to be spending their time manually creating categories. Create this if this is going to this. Like, why do you have to do that?
Yeah.
It's such
Because we already know the
it's such a mundane task that it should be all done with just a single click, right? So that's that will be unique combinations. Then using conditions will be, you will supply the conditions. So in the second one, the computer doesn't need you to tell it any conditions because you've already said unique combinations. But here we're going to use unique conditions. So let's create our first variables. So here, current use of any tobacco product, which is use of cigarettes or use of cigars or smokeless tobacco or electronic cigarettes or hookah or roll your own cigarettes or pipe or snus or dissolvable tobacco products or BDs. So current use of any of these 10 tobacco products, right? So
wait, so that's the context special. Can you zoom back? Yes.
okay.
Yeah. So where do you click it? Under what?
So we came to data processing, create composite variable, then using conditions.
Okay, so let's do that. No, I get.
All right. So these are our 10 products we're going to create any tobacco use. That this includes RYO right now. So let's expand this so that we can see clearly what we're doing. And let's zoom in a bit. So here we're saying if you answered 1 to any of these products, you're a current user. That's what we're saying. So we're just going to select all the ones. Select all the ones. So the idea is the definition is if you're a current user, if you said 1 to any of this, so that's why we're selecting all the ones. The platform helps you by standardizing the color. All items of the same type are shown the same color, so it's easy for you to visualize it. And so now we've selected, and you can see the count of the things you selected here, so you can't make a mistake. So there were 10 products, and we said if you selected one or one, we can just merge this. Right? So the platform will say, okay, we've created a variable here, which is 1 or 1 or 1 or 1. So to move this to this side and say we're done. So this is individuals who use any product. And then we can put all the other ones into a category, excluding missing. So assign remaining observations into a separate category, exclude missing. We always exclude missing values in case definitions. And now we've created our binary variable, which with, let's edit the label for this. This is 1, and this is 0. And now we can proceed to conflict resolution. The platform will automatically see if there are conflicts. So this is any tobacco with RYO, right? So the platform automatically does a lot of validation in the background to make sure they didn't make any mistake. It's like, you don't have to worry about that part, And so now it has created a variable, any RYO with any tobacco with RYO. Now we have to do the same thing, create any tobacco without RYO. Because remember our research question, how does the prevalence change with or without inclusion of RYO? So again, data processing, create composite variable using conditions. So this is our variables. We're going to select cigarettes, cigars, smokeless tobacco, electronic cigarettes, hookah. We are not going to include RYO this time around. Roll your own cigarettes. We're going to exclude that. Pipes, snus, dissolvables, and biddies. Now we have 9 products instead of 10. Done selecting. We can then select, let's make this bigger. So again, 1. So we're supposed to have 9 ones. This or 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 this, 9. Let's merge them. So that's created a category here. We're going to move to this side. This side is where you have your final products, final finished goods. Merge the remaining ones into one category, exclude missing. This now looks so easy now. If you were to write with code, well, let's just say that it's not going to be so straightforward.
Yes.
Alrighty, so this is 1. And this is, now if you write your code correctly, you will always get the exact same answer every single time. If you get it wrong, that means your code is incorrect. The platform is always correct. Because it is in this instance like this, it's very easy for people to make mistakes in terms of especially management of missing values. So here, this is any tobacco, no RYO, right? RYO. So now we have created our 2 variables. So it's detecting automatic for if we made a mistake, no mistakes, so it's proceeded. So next is for combustible with RYO, combustible without RYO. So data processing. These projects are kind of good because when you do the same task over and over, it sticks in your brain. So composite variable, again, using conditions. Now if you like to suffer, we can use the classic method where you now have to, it's a lot different, right? Yeah, well, I'm not even going to go there. Let's just stick with the visual. The visual just makes it much easier because color and just it's easier that way. But some people just like suffering, so we provide a classic for that. So let's create any combustible with RYO. So we have cigarettes, any product that creates a smoke. Cigarettes, cigars, no smokeless tobacco, no electronic cigarettes, hookah, yes, roll your own cigarettes, pipes, no snus, no dissolvables, and yes, biddies. So 6 products, including RYO. Let's make this big. And we're saying if you use this, or this, or this, or this, or this, or this. We have 6. Merge selected and move to this side. Put the remaining one in a category of its own. And now we can edit the label as this are users, which is 1, and edit label 0. And proceed, we could call this any combustible with RYO. And lastly, we have to now create any combustible, no RYO. So data processing, create composite variable using conditions. We select our variables, cigarettes, cigars, no smokeless, no electronic cigarettes, yes, hookah. We will not include roll your own cigarettes this time around. We'll include pipes, and we will include BDs. So 5 products. So we're saying if you use this, or this, or this, or this, or this, merge selected, that creates this group here, 1 or 1 or 1. And then all the other ones, merge them, exclude missing. So again, this is our 1s, and this is our 0. So this would be any combustible, no RYO. All right, so next, let's now record our demographic variables.
So,
Yeah.
question, are they, is it fast or do you need to slow down a little bit? Slow down a little bit? Okay,
Okay.
okay.
Alrighty.
Yeah, I have a quick question. Because actually has, like we were talking about creating a new variable. But it seems like, it's easier when you're recording and doing this composite with variables that are labeled the same way. So all of them are labeled categorical 0s and 1. But in Ashok's case, we could have something that says if you're 14, if your mental health days.
That we are not merging, we are merging the other two.
Yeah, no, okay. If we're merging
It is like number of teeth removed.
number of teeth
Okay.
removed,
Let me put on an example so that we can just do it as you
Yeah.
speak.
yeah, but they have different,
Got it.
Different categories.
Yeah, got it. So let's pull up a variable like, let's say, this, and no, let's say data processing, create composite variable using conditions. But this time around, let's create, to simulate your scenario, let's create complete different things. So just show you how you will walk around it. Let's use middle school and high school, and let's use current cigar. So we have a variable like this.
you're able to hide that.
Oh yeah. Let's hide floating. Okay. So here we want to create 4 variables. Middle school students who are smokers, middle school students who are not smokers, high school students who are smokers, high school students who are not smokers.
So in her case, it's more like if you're missing more than
60 there's one category,
Yeah.
1 to 5 more category, and all missing teeth category, and then there again don't know refuse.
Yeah.
Those are the removed.
So if you have more than 6,
Mhm.
and on the other variable, you have
If last dental visit in past
you're-
1
and
year,
Mhm.
2 years,
Yes, and your past 2 years is more than two.
Yeah.
Put them in
Yeah.
as a
Mhm.
okay.
So the issue here is dealing with operators.
Yes.
It doesn't matter what the categories are. So here, look at what we'll do. We'll drag the one, we'll put it in the other one, right? So drag with this one and put it in whichever one we want to move.
Put together.
Then it's going to ask you, is it high school or zero, high school and zero, high school not zero? So it's like, what is the relationship? Is it and? If it's and, you select and.
Okay.
Does that make sense? So in this case, I'll say high school and. So now it has created a category called high school and zero. So you drag and drop, and then you select the relationship. Is it and? Is it or? Is it not? And now I can now move it to this side. So again, and then here is what is remaining of those groups that were there. So this allows you to visualize what's happening in real time. Do you understand what I just did? So you drag and drop to whichever group you are trying to move it to, and then you select the relationship, and then whether it's and then when you're done. And it's also possible that you can just say, all right, this group, I want it to be alone with itself. Whatever this is just allows you in a more visual way to control whatever it is you're creating. So you drag to the group. No, it don't have to be same coding.
So zero I'm taking as last went to visit 0, less than 2 years, and other variables keep removed less than 6, 0. So those three I will match, right? 0, 0. Then that is 1, 1. That one and this one.
So it doesn't, you understand the context of your study. So you can drag, if you want to say 0 and 0, drag 0 to 0 and select and. So you're saying if 0 here and 0 here. If you're saying if it's a relationship, so you have to know whether the relationship is or whether it's and. That's your job. Your job is to specify the relationship between those two. If, for example, I'm defining current smoking and I say you must have smoked 100 cigarettes and you are a current smoker to qualify as a cigarette smoker, that means when I drop, I have to select and. Do you understand? Alrighty.
So for your example, to laws, if we want to create a category called
I just make 2 categories, more than 6, less than 6. And
Yeah.
for visit also, more than 2 years and less than 2 years.
yes. So but for the condition we are trying to approve, we can say for you to qualify for the new variable we're going to, you have to have more than 6 and
Less than 2 years.
less than 2 years for you to be in this category. But let's say we assume another thing and we can say, let's say we're trying to change the criteria. We can say you have to be either this or this to be that. But for your case is if you have to need to qualify to be categorized into as one and this new variable, is it you gotta have this and this for you to be eligible.
All right.
Categorize other.
So now one of the variables we're interested in is RYO. You know, in RYO analysis is rural status, urban rural, right? Remember, that's such a big criteria, but there's no variable in NYTS that captures whether you're rural or urban. So when you're analyzing secondary data set, you sometimes have to think outside the box. So in the questionnaire, right, there was no place where they asked them, do you live in a rural area? Do you live in an urban area? But do you agree that's a very important variable for analysis? Extremely, it's in fact, it's the most important variable. So in thinking outside the box, one of the things you can first of all go to is to say, I wonder how to sample this. I wonder how to sample this data set, right? Now, let's go back to our discussion yesterday. What aspect of sampling could give information about that? Remember, we talked about strata, talk about clusters. Okay.
What do you want to know about the places, not the people?
They won't know about the places, but do you remember the context of what we stratify, right? What do you say?
Strata.
Yeah, strata. Because sometimes we say, oh, we want to get information from rural people, right? but we're afraid that if we just sample them, we will not have enough of them. So let's divide the population into rural areas. So now, all of a sudden, the questionnaire does not ask questions on rural areas, but where can we get information about the rural area?
Census.
No. I'm talking about the particular survey. In this particular study, we're interested in rural and urban status for the residents. In the entire questionnaire, if we search the code book, let's go to the code book now. If you search rural, right, find rural. See, there's no information on, because the questionnaire did not ask you whether you live in a rural or urban area. But we really want that variable. So now we said, okay, we can't look at the code book, we can't look at the questionnaire, that information is not available there. But where can we turn to get it? Analysis of secondary data requires you thinking outside the box.
Think of a proxy,
A proxy, okay,
proxy variable.
okay. And in this case, we have to turn to sampling. Remember we said, if only the stratified by rural or urban area, that means we can get information about that from the strata.
Mhm.
And where can we get information about the sampling? Which documents? Is it the data dictionary? The methodology report, exactly. Now we have to go to the methodology report and say, okay, did you guys stratify by rural or urban area? Because even if that questionnaire does not have the rural or urban, the sampling design has it. Do you understand what I'm saying? So this is why you have to know about sampling designs, and this is why we have to take that courses today to understand the one today. All right. So now let's leave this code book and let's head over to the methodology report. And now here we'll go to the end, chapter 2, sampling methods, how the study was sampled, right? So you see the sampling design. So the sample was a stratified 3-stage cluster sample. Primary sampling units were stratified by race, ethnicity, and guess what? Urban versus non-urban, rural. See, now we're having good news now, right?
Yeah.
The methodology, the questionnaire did not have rural anywhere, but the methodology was done such that individuals were stratified by whether they lived in a rural or urban area, right? So now we have to just figure out how were they stratified, right? So let's look ahead. Now, so that means that when we are looking at the questionnaire, when we're looking at the data set, which variables should we look at to give us information about rural or urban? Will it be weight, PSU, or strata?
PSU,
Wrong.
strata.
Right. Why? Why will it be strata? Exactly. They just told you they're stratified by rural urban. So where will you go to get the information? Strata variable, of course. Now, here's what the strata variable looks like, right?
Thank you.
So remember they said they're stratified by racial group, Black or Hispanic. And then, so you have stratified by race, and then you stratify, also by rural or urban. So what does BU1 mean? Who can guess what this means?
Yeah.
Black urban, very good. Black urban 1. So this is the first stratum, that is Black urban 1. Black urban 2. Now, what is BR1? Black rural 1, right? What of HU1? Hispanic urban 1, Hispanic urban 2, and what of HR1? Exactly. Now, so that means that if we only went to this variable, how would you now classify a variable that is rural or urban?
The urban rural based on the things.
Exactly. And so, just like magic, even though the questionnaire had not a single word of rural, with our knowledge of study design, can go back and create a variable, right? We just go to stratification variable and regenerate it just like that. So if you know what you're looking for, the answer is always there, right? That's why 2 people can take a secondary data set that is available, and one person just does magic with it, and you're like, how? It's like, it's not the same questionnaire. Well, the problem is that you're looking at the questionnaire only, right? The person's looking at the design and doing great things with it. So let's do that. Let's create a variable for rural or urban status from a stratum variable. So let's go back to our data set. So let's search for the stratum. So this is a stratum variable. So you already see, you can already see HR4, whatever. So let's recode this variable. So that means that we want all the ones that have R are rural, remember? So we're going to select this and select this, select this, select this, oops, select this. This is urban, this is urban, this is rural, select this. This is urban, this is rural, select this. This is urban, this is rural, select this. This is urban, this is urban, right? So we've selected 8. We're going to merge all of them, merge selected, and confirm that indeed we have all of. So rural, so all the remaining ones are urban, right? So we're just going to select all the remaining ones, of course, exclude this one, and again merge those ones. And like that, we've created a binary variable that indicates whether you're rural or urban. Now let's just edit this label to rural and urban. And that's it. So like that, we've created a variable for rural or urban. Again, you need to know where to look for things. That's the moral of the story. Not all answers are found in the questionnaire. Some are found in the study design. Okay. So concepts like clusters or stratification shouldn't just be abstract construct. They should be practical because they store key information, but you have to know where to look. Does that make sense? So let's call this variable what? Rural. Let's call this or dwelling. And let's proceed. So at the end of the day, it's not so much about tools, but understanding what you're doing and just working efficiently. So that's what it boils down to at the end of the day. Now let's record the variables for school level. So school type, let's record this into middle and high school. So from a code book, 2 is high school and 1 is middle. So I'm going to change this to high and 1 is middle. And this will be grade level. I'm going to call this grade. And then we have also the sex of a student. I'm going to recode this from a code book. 1 is female. So I'm going to label it clearly, female. And 2 is male.
Why don't we change it to binary? Or doesn't matter?
No, for this one, binaries are for your outcomes. These are just variables for like characters, characteristics. Like think of them as predictors and outcomes.
So it's better not to change the predictors?
No, so you can read it. When you say the prevalence of this was 50 among group 1 and 60 among group 2. It's like, what is 1 and what is 2? It's better to say was 50% among females.
Okay.
And 20% among males. I know what I'm talking about. Like, do you understand?
Yeah.
Okay. So male.
No, but I was wondering, it's like the category, it says discrete here.
Oh, because it was 1 and 2.
Yeah.
The platform doesn't know what.
There's missing.
Yeah,
Yeah, the platform doesn't know what sex means.
yeah, but doesn't matter, right?
It doesn't matter, right? All it knows is that the variable had 1 and 2.
Okay.
So the classification is not based on the name, it's based on the values. Do you understand? All right, so we're going to call this gender. All right, so we have recorded. Let's see the progress we've made so far. We've created a variable gender, grade, the type of dwelling. We've created our outcome variables, any combustible with or without RYO, and any tobacco use with or without RYO. We now have to create the variables for the exclusive groups. Those 4 exclusive groups. So let's do that. So for that, we'll come to data processing. We come to create composite variable. Now we're going to use using unique combinations, right? Using unique combinations. We're going to select those 2 variables that we're interested in. That is cigarettes. So let's current cigarettes and RYO. Let's see, roll. So here I have selected the 2 variables we want to create. We want to create, unique combinations of. Take note that I've done it in such a way that I won't end up confusing myself. So I selected roll your own cigarette, which was coded as 0 and 1, binary, but left the current cigarette in its original, state as discrete. So that one has 1 and 2, the other one has 0 and 1. So I can easily see which combinations correspond with which. Otherwise, if everything is 0, 1, 0, 1, I'm not sure exactly which one is 0 and which combinations are. Does that make sense? So that's just an easy way for me. So you creating unique combinations, you select the variables, and that's all you need to do. No more, nothing more complicated than that. So I can now call this variable clean groups, clean RYO, or let me just call it unique RYO and cigarettes, SIGs. So those are the unique combinations. So let's create that and let's see what that looks like. You are going to check this box if you want to create categories for missing values too. But in this case, we don't want that. We want 4 groups as we defined earlier, and then the missing groups will be kept as missing. So let's proceed. So it has created the variable. Let's see what that looks like. So see, unique RYO6, that's a categorical variable with 4 unique values. So you can see that. Let's see what the unique values are. So we have let's create let's give them names. So let's look at let's recode them. So we have 2, 1. Which group is this? So we have 2, 1, 1, 0, 1, 1, and 2, 0. What group was this? When you're creating unique combinations, you want to be very careful. Otherwise, you don't want to go and mischaracterize a group, right? So if you're not sure, what you could do is make sure that you do a cross tab so that you're seeing it in real time, right? So what I'm going to do now is I'm just going to take a screenshot of this, and we will now compare that with. So let me just take a quick screenshot of this, and then we can look at the cross tab. So I know what they are because I selected the variables, but I just want to show you how you can trace it back should you get confused ever. So let's look at the cross tab of those two variables. Remember we selected RYO and cigarettes. So let's look at the cross tabulate of RYO and roll your own. So we want to do a cross tab. So this gives us the combinations here that corresponds to what we had. So our clean groups. So guys, this is the most important part of analysis, right? Like we said earlier, generating the results is it's just a press of a button. The hardest work is understanding what you're doing and getting your data ready for analysis, right? So yes, and that's why that's why you're in a training program, to make sure that you understand the process clearly. All right, so this is cigarettes and this is roll your own. So 202 means this is 202 where current cigarette is 1.
The one that we created the binary for, or this one?
It doesn't matter.
Okay.
It doesn't matter. It just so you don't end up confusing yourself. If it's 01, 10, 11, you might have been getting confused.
But isn't it better to put the same ones?
It's up personal choice, personal preference.
So if we want us to slow down, if you need everything slow, because I feel like some of us are lost.
I think I agree with you. I think there's a great deal of
Yeah. Some of us are lost somewhere. So or maybe after the break, or maybe we can catch up during the break if you take a small break. Like the food is here, then we'll catch up, and then after the break we'll
things will normalize.
Yeah.
But what do you guys think? Like, what's been the experience so far?
A lot to take in.
It's good, but there's one thing I don't like, honestly, about the platform.
Okay.
I can't do Control Z and go back.
Oh,
I literally deleted the data set 4 times because I do something and then, for example, when I did the recoding, I just pressed enter and the whole thing got changed.
yeah, but you know what? We cannot allow Control Z because it's an ecosystem. You could have made changes, and it's a collaborative platform. You could have a million people working simultaneously. So what change? So even though they're working together, right? The system logs changes at discrete packets. So what change should be undone? Is it the one done by Mr. 100?
Yeah, makes sense.
So
Frustrating, trust me, at a certain point.
So if you make a mistake, how do you undo it?
Yeah.
if you make a mistake, you can go to the log of your activity, right? So let me show you here. You have a analysis history that has all the things that every single thing you're doing is logged. You can choose to rerun it from there. You can, and that's why some basic principles apply. Don't override a variable. When you're creating a new variable, always create a new variable, not just say recode and replace. That one, it doesn't matter the platform. If you replace the variable, you've replaced it. And if you say a mistake, well, you can't override a variable in R and say I want to do Control Z.
Yeah, but
The variable has been.
go and run everything from the beginning and then run it again. It would be like clean.
Are you trying to say you just want to run the procedure or what?
No, if I did a mistake, I didn't know about this. So
Okay.
I deleted the whole data set. And
Oh no.
that could be-
Oh no. That's why you have a code book and you have analysis history. This is
Yeah,
history.
I had no idea that I can.
So under the action, there was take one of the actions. So if you want to, okay.
So here you can see, and depending on the type of action, right? If it's an action that allows rerun, then you have a run, or and then depending on the procedure too, depending on what you're doing. So for example, if you have this document we're talking about, if you know you can back it up. In this case, there are triggers for backup. So you can always revert to an earlier stage of whatever work you're doing. You know.
It's a good thing. But now I know.
Okay.
Thank you.
Okay. So, yeah, I think, where is Hanuf? Hanuf, where are you? Are you lost somewhere?
No, I just have the first part.
Yeah?
I stopped at the first part.
Oh, you are right behind me there. Well, this is following bumper to
Oh,
bumper.
Okay.
All right.
Regard, are you for you?
Yeah, I'm doing the first part. Yeah.
Okay.
Oh, the first
Okay.
tab, okay. How's your journey with your data?
It's going good. I'm almost done renaming everything, so I'm just waiting for the analysis. So
Okay.
I could start.
And we're almost done. Wait, that's the last variable we have to create. After that, it's like
Okay. Yeah, I think we're almost at time to take a break.
Exactly,
right?
yeah.
So that we can have a little breather and eat. Deleting your
It just
data.
feels like that thing like, about my insurance.
so let me just quickly tell people. So guys, we're taking a break. This is a 1 hour break, right?
Yeah.
So online folks, we're taking an 1 hour break. So we're back in 1 hour. Thank you.
There's the actually then.
Yes, I know, yeah.
Yeah.
So I can
go
join and instead of, we have like 4 minutes.
Okay. So feedback. Are we going too fast, too slow? What would it change?
I think it's a really good place.
Okay.
Yeah.
Well, that's good. So what do you prefer, writing code or between the platform and your coding, which
If I complement your application, will you convince Dr. Ogbo to make my thesis using this?
well that's yeah.
I'm just kidding. I think it's like it's a game changer. Yeah. But like the important thing for us, as you mentioned earlier, like dental epidemiologist or dental public health resident, the ideation and
Exactly.
like what goes into it, because at the end of the day, the analysis is just pattern, but you
Mhm.
need to be able to
Exactly.
justify it, like, or defend it in a sense.
Exactly. Tools are just tools. Tools will come, tools will go, and new ones will come. But the basics still remain, fundamentally the same, right? So,
This is a very important thing, you just said. There's an argument I saw on LinkedIn. The argument was, back in the days before computers and coding R on these softwares, people calculated these statistics by hand.
mhm.
Can't imagine.
Yeah, there was a time they were using card or clipboard or whatever they were using.
And the errors that come with that.
And after that time, we moved on, right? We moved on into the SPSS era, right? Nobody rarely even uses SPSS these days. And we moved on from SPSS. Stata was the thing. People still use Stata. And SAS was like, if you didn't use SAS, like you are not breathing again, you're not the human being. Moved it, R was more automated and things, and people moved to Python. And now AI is here. Vibe coding, we have to accept it. This transition must happen. There's a time where this whole R code that we're doing is going to be mundane. It's going to be out of, like, if you're doing it, people like, huh? What are you doing? Like,
Yeah.
you still, there's
But
still
the
more-
caveat is like you still need the basic.
Exactly.
Yeah.
Exactly.
So the basic still remains the same.
Mhm.
The basic fundamental of epidemiology, understanding how to define your outcome, understanding how decision making that goes into data wrangling, data cleaning, how you define your outcome, what is, if you want to use logistic regression will still interpretation of logistic regression, all those things are very, very fundamental, and you must know that.
Mhm.
The math behind it, actually, why you would choose logistic regression, or why you might do a modified version of a logistic regression for this. The math behind it is actually very important. So it's not the tools will transform. But for now, we still want you to do these tools, this R, because we know that doing this R will help you understand how these things connect to each other. How the outcome variable connects with the output variable. That's how it's written.
My students at UCSF, I find it quite frustrating because it's spend like 95% of the time fighting with SAS code. Like, first of all, they don't understand the code, and they'll never understand the code. And then never get the project done. And then it's like, oh my goodness, like something has to give here. But it's quite an interesting conversation, though, conversations about tools and
I think the whole of CBC still uses SAS logic.
yeah, but it's just evolution. People are moving on, and people,
Wow.
and that was, Office of Science. One of the questions then was like, what tool? I don't think I've ever like recommended a tool. I was like, use whatever. I'm not interested in tool. I'm interested in the answer. Whatever tool works, that's what you should use.
Except sometimes teachers tend to have a preference, like
It's based on what they use. So if they are teaching a course, if they can explain to you, they can only explain what they know. So if a professor uses R, well, you can't bring SAS code and because students what they will do is they'll now bring the code and say, "Can you help me debug it?" It's like I can't because I don't use it. And so but for me it's always like preferred software would be this. But all methods classes I teach, I always say we can use whatever you want. That's up to you, but there are no multiple shades of the truth. There's only one correct answer here. So all right. So all right, so welcome back to our afternoon session. Let me get still screen sharing. So since we didn't have some clarity of how the history works, I'd say that let's but as feedback, right? Is it that it's not conspicuous, or is it that the button is not conspicuous enough?
I didn't see.
Okay,
And I'm a person who sees that.
but it's also a new thing to you, so
Yeah,
that's
But like I'm a person who regularly, I'm a person who would pick up things quickly
Okay.
on like a screen.
yeah.
So I would.
Okay, that's fine. That's no problem. All right, so we created a variable for the unique combinations. Now, we have not recoded it, or we have not reassigned labels to it. We only know that it is 1, 1. So in this kind of case, we want to go back to the history so that we can see how the history can help us know which one was 1 and 0, which one was 1 and 2. So if you don't know the elements of what went into an analysis, you can always go to the analysis history. Every single analysis you do is logged, because we also talk about the FAIR standards. Are you familiar with the FAIR standards for data? Data must be findable, accessible, interoperable, and reusable. Those 4 standards mark what qualifies as good data practice versus not. So yeah, if I run an operation, yes, I have to go back. I should be able to know exactly what I ran. And because in some sense, that's what people talk about when they talk about reproducibility. But reproducibility is not only enshrined in code. Reproducibility is also enshrined in how we engineer systems, like logging. You can have an audit log of every single thing you did so that you can go back to it. That is, reproducibility as well. So here, for example, we created a composite variable that was 2 hours ago. And we can know exactly what variables we use to do that. So let's see, can view the details, for example. Okay. And for those who are very interested in code, the history gives you the procedure in the code format, so that you can see what went because obviously, obviously there's code behind the process. It's not as if where the system is someone is running and picking an answer. That's code. Code is what makes it come alive. So you have the code there to help you guide you. So let's look at the specific composite variable we created. Let's view the details. So this was what we used. We used two variables to create those two exclusive groups, cigarettes and roll your own cigarettes. So you can see, if you can remember, this was 0, 1. This was 1, 2. This was the numeric version, the discrete form. This was the 0, 1 recorded. So that means that cigarette, so that allows us to know exactly the values. So again, remember, cigarette is 1 and 2, and roll your own is 0 and 1. So let's go back and assign those variables properly. So these two parts, again, these two buttons are toggled. So analysis history, codebook. Analysis history, code. Clear now? That way you can always find your way. So in case you're wondering, where is the codebook? Well, maybe on analysis history.
It's something that like, if you go to analysis history, is there like a delete button?
It's
Delete.
well, it's not very good practice to delete it. Again, it must be
This is
findable.
log.
Yeah, exactly, it's a log. It's an audit log.
Yeah, but if, for example, generated crosstabs and oh, it was a mistake. I didn't want to generate crosstabs. What should we do?
So you can. It's just part of a history. We're not. It's not a good idea to erase history, is it?
Yeah.
Yeah. So the same thing here.
Thing that I made.
You can just run it again. You don't have to. You can just run it again. You made a mistake. Yeah, you just try it again. You don't have to worry about deleting that history.
Make a crosstab again, a new one with a new name.
Exactly.
That's like new, for example.
But if
It will always be there, like the mistake you made, but you don't have to use it in the analysis when you choose.
Yeah. So the fact that it's there doesn't mean it's going to appear in your manuscript.
yeah.
Those things.
Yeah. Yeah, but in general, when you're engineering data systems, you want to make sure there's an audit trail that is immutable, that is always there. Because that's what data integrity represents. Does that make sense? But the same user that deleted that history will be the one who will come back and tell you, where's that my history? It's like, oh, but you deleted it. But they have forgotten that you deleted it. you know what I mean? So now let's now go back to our code book and create the group. So again, remember, cigarette was 1 and 2, and roll your own is 0, 1. So let's recode this and assign the names. So 1 and 0. So first of all, this is 2 and 0. That means these are the use neither, right? So edit label. Let's call this use neither. So confirm. 2, 1 again.
Exclusive RYO.
Exclusive RYO. Okay. Are you sure?
I don't know.
Okay.
I know it's one of the exclusive.
Okay, I had a screenshot here. Okay, so cigarette was what? 1 and 2. RYO was 0 and 1. Right? So two,
So it's exclusive cigarette.
exactly. So this is exclusive cigarettes. But when you're not sure, what should you do?
Check with the
Check. Don't assume. If you have a moment of doubt, check. So what we're going to do, we're going to go and check. Now, if you want to, this is a web platform. That means that you can, you can always open a new tab. So let's open a new tab as just app.chi-square. So you can have multiple tabs, so you can just cross-check your work. So here we're going to go to data analysis. And this is the work we're doing. And we're going to go to cross tab and select the two variables that we're interested in, which is roll your own cigarettes and cigarettes. Right. So these are the two variables we're working with. And let's cross-tabulate them. So this is roll your own cigarettes. So the value of 122 is individuals who use roll your own. And oh, sorry, I selected, I selected, let me select the exact thing we had on on that.
Yeah, that one is combined.
Exactly. CCIGT. So whenever you have any doubt, don't just push ahead. Don't just say, I think this is this. No, this is how we start making mistakes. Right? Always confirm. Always never assume. So the 15,981 are individuals who reported that is no use for cigarettes and no use for roll your own cigarettes. No use for cigarettes.
So 2 means no.
Yeah, 2 means no in the original one. No use for cigarettes and use of exclusive users of roll your own 122. So 122 represents exclusive roll your own smokers. So let's go back to 122, exclusive roll your own. See, you have misled us. You said exclusive cigarettes.
I said no. The first thing I said, "Oh, you made me question it." I changed that.
But that's the point of checking, right?
My instincts were right.
See, but the goal is that the point is that we should not trust instincts. Exclusive RYO. Always check. And if you are QA can never emphasize enough how important quality assurance is. Check and check again.
Yeah.
Then let's go back. Those who use cigarettes but don't use RIO, exclusive cigarette smokers, 690. So 690 exclusive cigs. Oops. Exclusive cigs. And then this one is dual use, 1-1. But again, always check. It's easy to, so 1 here. So that's dual users. So now, no, not that one. 1-1 here. So dual users.
So can you do this at the renaming or relabeling type when you're collapsing things together?
Yeah, you can, but it's just easier when you composite variable, just 1 click, as opposed to 4 clicks. So, yeah, the degree of user burden can easily be quantified with number of clicks it takes you to execute one action. So, any day, I'll pick 1 click over 4 clicks. So, so now we have created our variable with 4. Does everyone remember how we created this variable? Okay.
The 4.
So we just clicked
Combination.
on, exactly, we selected the variables and used, let me just show you again for those of us who were not
Zoom
here.
out.
Exactly. Context.
Yeah.
We need a context window. Exactly. We're regressing. To see the big picture. That is so funny. All right, so we can call this SIGs, RYO. Let's just call it, make it simple. Oops. How do we hide this thing again?
100%.
Hide names of, okay, hide floating controls. All right, good. So we created a variable by coming to data processing, create composite variable with unique combinations. So it just creates unique combinations of those. So we are almost done. I think the only variable we have to do is age. We didn't create a category for age. There are some variables that you should just almost always include in your analysis. Age, sex, if you're doing population research, and there's almost never an excuse for not including those variables. P-value or no p-value, right? They're key variables that help characterize the population. So let's quickly recode our variable. In the original data set, that's the very first variable in the data set Q1. So let's recode it. So these are the values of age. Never assume that the values correspond to the actual ages. They could just be codes. So let's recode age. So let's go to the code book and see what each of those values mean. So the age is Q1. Let's go all the way to the top of the questionnaire. So this is the last variable we'll create before we go to the analysis. So this is the hard part of an analysis, right? But this is the most important part. The part where you get the work, the data sets and everything to the state where they ought to be. So you should pay very close attention to this part. Yeah, that's where we're looking for the actual, because don't be deceived thinking that 11 means 11 years. That's an assumption that could kill. Make sure that 11 could mean 25 years old. You never can tell. Okay, right, good, right here. So this is the code book. This is missing. So you have two missing categories here, double asterisk and completely blank. So those are missing. So we would combine them. So we'll just set this to missing, treat category as missing, and treat category as missing, right? So both of them are go to missing, right? There can only be one type of missing. So if for a category you don't want, just set it as missing. Then we can collapse this so that we have pre-teen years old, pre-teens, early teens, older teens, and younger adults in a way that makes sense. So pre-teens will be from the youngest age to 12. Then early teens with 13 to 15. Then 16, 17, and then 18 or older will be young adults. So let's record that accordingly. So what are the codes for early teens? Where is the code book again? So 1 to 4 are early teens. Okay, so pre-teens. So 1 to 4. Let's go to so 1, 2, 3, 4. Oh, they're scattered everywhere. So 1, this. So 1, 2, 3, and then where's the 4? Okay, good. So right here. So this, right? So yeah, so we've collapsed all of those. So we'll call this pre-teens. So 1, 2, 3, 4. So pre-teens. We can call it 9 to 11. Was it 10? Is it 10 to 12 or
9 to 12.
the 9 to 12?
To the wrong number, like 9, for instance, instead of 4. How can I see?
You can
But
you can reset. You can reset progress. Do you see this? You can reset progress. Yeah, to reset everything. Yeah.
But this is what you're asking about. So reset progress.
Yeah, but it did it for everything. Doesn't delete the last one.
Oh. It did it to everything.
So it resets the whole page. Yeah?
Yeah, it does that, yeah. Because the reason why,
I understand.
yeah.
Very valid reason.
Yeah, and also some of these things that look very easy. Oh, just from an engineering perspective, it's like pulling teeth. Because you have to exactly. Because you have to keep each operation in a single state, and then there are huge memory implications that you have to, sometimes it's just easier to because you have to balance efficiency with actual performance. And so sometimes you have to make some decisions that, okay, this is, all right, so we have created preteens. Next is we have to create, those aged 13 to 15. So what codes are those? Sorry? Yeah, 13 to 15. So 5 to 7. So, so 5. So you can also just select 5, 6. Where's 6? 6. So you don't have to drag and drop. If that's a lot of effort for you, you can just select the boxes and merge them. That's faster too. But if you want to drag and drop, that's fine too. So let's call these guys, yeah, early teens. And that's 13 to 15. Then older teens, that would be 16 and 17. What groups are those? Eight and 9. So that's funny. So older teens. We had a lot more vibration in it, but we dimmed it down. Like it felt like PS3 where you're playing it. Like, I don't want to run people's batteries down. Exactly, like, because it was like, oh, how do you make it analysis fun? It doesn't have to be boring, man. Exactly. So, yeah, because the idea is that when something has merged, your hand should tell you that this thing has merged. So older teens, that is 16 to 17. And then lastly, younger adults. That's the remaining ones, 10 and 11, right? So 10 or 11, so that's older adults.
Yeah.
Sorry, young adults. So young adults. 17 to 18. Sorry, 18 to 18 or 18 plus. All right, so now we have created our age variables, age cats. My own naming convention is I always give a variable and I count the number of categories, 1, 2, 3, 4. So I call it like age cat 4. That allows me easily to know the number of categories easily. So if something is wrong in some output, I can say, oh, but I expect X number of items here. And then we can proceed with that. So we have created all our variables now. Now we can go on to the next part of our analysis, which is now the actual generation of estimates. Now, this is complex survey, so we have to account for the complex design. The analysis mode is here. Right now it's unweighted. To set the data to complex survey mode, just click there and select the variables for weight. The platform automatically selects every variable that is not eligible. A weight variable must be non-zero, non-negative, and non-string or non-alphanumeric. So weight can only take on positive values, cannot be negative, cannot be missing.
Actually, can you see a weight variable? We have, oh, okay.
Okay, so yeah, so it filters out any variable that could mathematically not meet that designation, so that you don't mistakenly go and select a variable and then it throws errors, and then you're like, oh, but why is it throwing errors? Then PSU, select our PSU, stratum, we select our stratum variable, and we save. And now, everything
have to have PSU
it does not have it does not have to have a PSU.
because I have weight and stratum only.
What kind of scenario will you have that the data set will not have a PSU? In actual sampling, what can you think of a scenario? So the answer is yes, it's possible not to have it. But to test your knowledge of what we learned yesterday, can you think of a scenario where a survey, complex survey, would have stratum and we'll have
When we have places
Yeah.
that select people.
Hmm?
Is it like when we select based on places, not
So,
individual
so you have weight and you have what?
stratum.
But you don't have PSU.
Yeah.
Okay. Think of, so in this case, right, they had a list. Remember, you must always have a list, right? They had a list of what?
Equal
People.
ID, yeah.
So if there's no PSU, that means that they started with a list of people. But they feel a need that, so let's say, for example, the BRFSS, right? BRFSS is a landline. One way you could have designed it. So let's say you go to a country and they actually have everybody's phone number. And you choose to say, oh, well, I already have the mobile phone numbers. My survey is going to be a digital survey anyway. It's not as if I'm going house to house to knock on people's doors. So I already have a list of people from maybe the country's telecommunication office. But I still want to stratify because I say, oh, maybe they have landlines and they have cell phones. And cell phones are representative. There are a few number of cell phones, but most likely than not, those cell phones present older populations.
Mhm.
So if we were to just draw a random sample of all phones, we'll get only a very small number of older adults. So what do? We decide to stratify cell phone owners and mobile cell owners. So now we've created strata, but they're not PSUs, they're not clusters. Does that make sense? In that case, your survey will end up having weight. Why? Why will you have weight?
Make it more.
Because in some, there are some rural areas in the south.
Yeah, but why will it have weight? Because, but why will it have weight? Because selection probabilities are
Different.
Yeah.
different.
Yeah, that's.
Exactly, because we probably applied different sampling fractions to landlines and cell phones. So inherently, we have created inequality in the probabilities of selection, which we have to correct with weights, right? And so we have weight here because of that, and then we have strata, obviously, but we don't have clusters because we didn't use clusters. PSU stands for what? Excellent. You need to be teaching this course. Primary sampling units, right? Primary sampling units. What does primary mean? What's another word for primary? Initial. Primary teeth, the first set of teeth that come in the mouth. Primary school, the first school you attend. Primary sampling unit, the first sampling stage. So you select clusters. That's the first sampling unit, right? So you might have weight and PSUs, but no strata. You might have weight and strata, but no PS. It's your job to know and explain why that, and it's your job to be able to design. If you're put in a country and asked to design, it's your job to know which is more efficient. Nobody's going to come and make those decisions for you and say, oh, what should we do? Well, that's why you're an expert. You're supposed to design it accordingly and say, well, in this scenario, I think we should do this way because I strongly recommend it because of so and so. And it's going to be more efficient this way.
Yeah,
Right.
because, I think he's going to lead one of the major oral health survey in Kuwait, so it's going to reference with it.
Exactly. So
That's good. So, but the other question I have is, this also brings up the debate on should you weight or should you do unweighted? Do you do weighted or unweighted? And realizing that the variance significantly increases, and the introduction of weight slows the variance, right? And question then becomes, in a case like that, is the ideal thing to do, you analyze your data unweighted and then analyze your data weighted, and then kind of look at both of them and say, if the estimates are somewhat similar, I mean, there's an argument that if the estimates of the weighted and unweighted are somewhat similar, then you should go for the unweighted because of the you run away from the issue of variance, like overinflation, like having variance issues. So is that the case? Is that something that also in practice that you've experienced in terms of analyzing or doing weighted or unweighted versus population?
So in general, so the three sides to the coin, right? You have the weight, the PSU, and the strata. the weights control the point estimate. So if you have 10.1 and confidence interval, the weights are controlling the point estimate primarily, and then the strata and the PSUs affect the confidence intervals. Primarily, we wait for point estimates, for prevalence estimates or mean estimates. And so there are a lot of debates about, the relevance of weights in regressions in general. But primarily, we're concerned with the implications for prevalence and means. So yeah, if they're on equal probabilities, yeah, you should in general wait. I think the problem is that most times people focus about weight a lot and sometimes forget about PSUs and strata. Nobody talks about those two. For whatever reason, even though they are equally important.
Yeah.
And so I think that, if for example, you stratified a sample and you forgot to weight it, you will have wider confidence intervals than you ought to have had, right? And in this case, no longer the fault of a weight, it's the fault that you forgot about so you're like, why is confidence interval so wide? It's like, wow, did you account for the stratification? Because stratification builds in efficiency in the study so that it narrows the confidence intervals. But in the absence of that, so I think it's an issue of emphasizing all three. I call it the statistical trinity.
And then comparing. Not that it is only one, but it both and then the book compare.
Well, the good rule of thumb is if your data use or had unequal selection probabilities, you should weight the data, period. Like, you can compare, but that doesn't, the comparisons may even be similar for some groups, but what are the groups you did not compare? How do you know what the results would be? There's always that part that you do not compare, right? And then it's, so it's the general rule is if your study utilize complex, because by implementing with unequal selection probabilities, you are injecting selection bias into the study. And it's like, oh, I don't worry, I made a mistake here, but it's not a mistake, it's by design. I'm going to come back to it and correct it. Well, failing to weight data is now leaving the mistake as was without correcting for it.
Yeah, totally, I agree. So that's the argument.
Yeah.
Probably study and the argument, because knowledge-wise, what I have also noticed that weighting is always very important, but there is always this alarm, this warning that, okay, yes, weighting is important, but sometimes you should be cognizant of the fact that weighting introduces its own estimation of the variance. So yes, you should weight, but should you also do, so that's the question, should you also do an unweighted analysis and make comparisons and say, both of them, but they are much different, because like an equal probability of sampling, like you said, they say somebody called on the phone, you called some people on the phone and you collected from in person. There might actually, in real world, there might actually not be any difference, so to say, but you weighted it, but then what is the bias variance trade-off?
Yeah,
right. That's it. How do you balance?
Yeah, I think it should not be comparison between weighted and unweighted. I think it should be comparison of different trimmings of the weights.
Okay.
When we weight data, like you said, right, we have extreme weights. So a key component, the key part of weighting is trimming of the weights. It's like you have a haircut and you're like, oh, geez, this hair strands are so high. I'm going to trim some of them off so that everything looks a bit harmonious, right? So trimming of weights. So again, that's something that's not very easily widely acknowledged or implemented properly. So the variance it could not be a problem with the weights, it could be a problem with the trimmings of the weights or the absence thereof. And then who gets blamed? The weights. It's like, no, but it was implemented incorrectly. So instead of blaming the weights, maybe we introduce better, education on how to weight properly and how to trim the weights properly, so because the issue here you're addressing is one of extreme variations in weight, which introduce extreme, variances, so that I think that is at its core, that's the fundamental issue now involved there.
I have another question.
Yes, please, yeah.
So when my code book provides me two different type of weight, like the first one not include US territory and the other one include US territory. So the first one has missing. It doesn't show up in the weighting. Like when I try to choose a data variable, it doesn't show me.
Yeah, because weights cannot have missing values. So
Then what's the point they provide us that?
if
How can I use it if it has missing?
so in that, so if it's missing, that means that the weight is for only America, only mainland, only the main US.
You need to extract.
Yeah.
You need to make it a different data, like
Yeah.
all the data associated with that which needs to go a different data set.
So
Because
It-
I'm comparing region,
Yeah,
and
yeah.
when they did the region, they did not include the territories.
can any human being have a weight of missing weight? What if a human being has missing weight, what does that mean?
He doesn't exist.
Yeah.
The person does not exist, right? A missing weight is the same as what conceptually. Think of it as on an actual scale. What is the closest number you can equate to a missing weight?
Actually,
0.
miss-
The guy is missing weight. It could be the guy had weight, but then died and whatever, right?
Not
So-
representative of anybody else.
Exactly, yeah. So one way you can do is because if you put a variable, if you weight on that data set variable, you will have errors in your analysis consistently. The platform is trying to protect you by saying, well, you cannot add this variable. It's flagging errors to you that
Okay.
you have fundamental issues with your weight variable. We cannot allow you to use it in its current form. It's your job to go and figure whatever the issues are. We don't know what the issues are, but what we do know is that variable is not a good variable. It has issues.
So it's when you're only talking about territories, right?
Yeah,
Oh.
because the region I'm using, I want to compare the coverage and region for regions. They didn't include the territories in the region.
Okay, so the thing is that when you want to now do the analysis for the territories and versus an analysis for the region, it's still essentially the same data set, but what you now pull is the ones with the weight for that region will have its own unique, is essentially the same data set, but you still have that weight for the region, right? When you're doing
I'm
analysis for the
using
region,
territory weight.
you need, yes, if you're doing the territory one, use territory weight. If you're using the region one, you use the region weight.
But the system will only allow
Just
me.
you cannot
So
just
that's what you
replace it with
separate the data
zeros,
set.
or you can just replace them with zeros. All the missing values for weights. That's what I was asking you conceptually.
Oh,
What does missing weight mean?
0. Okay, I see.
When you have
Yes.
weights with zeros, what the computer is doing is you're going to throw them out of the analysis anyway. They're not represented because zero weight means the guy doesn't stand for anybody or doesn't count.
Yeah, that's a very good one, yeah. You put zeros and then you can then use it. Or you separate, you have two data sets.
All right, now let's start our analysis. We said analysis is the easy part. We're going to use the analysis wizard. Who remembers what I said about the analysis wizard yesterday?
What was the question again?
Who remembers what I said about the analysis wizard yesterday? If you're unsure of what you're doing, this is where you should live and die.
Yeah.
You should never leave this part. All right. The analysis wizard is your friend. So here we want to set up analysis, but we have no idea what to do. We know we want to write a paper, but we don't know anything about. We just know that we have some variables that are important to us. But that's it. That's all we know, right? So let's go through that process now. So click on the analysis suggester. I'll select the variables that we care about. Let me context window if I get reminded. So for each of this, you have the justification, which is supposed to educate you. So the first one says, choose the single most important outcome variable for your analysis. So here you have the justification, main outcome, and why it matters. So it says every study needs one main outcome. Just like a ship can only have one captain. So we're trying to use terms that everybody can understand. Simple language. If you have several possible outcomes, choose the most important as your primary outcome. The others can be listed as secondary outcomes. Your primary outcome should be the variable that best represents what your study is about, the one you'd mention first if asked for a quick summary. Factors like impact, prevalence, stakeholder interest, and data quality, like completeness, can guide your choice, right? So that's to educate you on, in case you're wondering, why do I need this outcome? Well, now you know. So in our case, I'm going to select this as my primary outcome. This was the variable, the 4 exclusive groups, as my primary outcome, and you select the type. Is this an ordered or an unordered categorical variable? It's unordered. Very good. Next, we have to select secondary outcomes. Justification. It says we also have to select at least one secondary outcome. Secondary outcomes add depth. They help check whether results are consistent and they strengthen your story. For example, variants of the same outcome, for example, cigar or chewing tobacco use when the primary outcome is cigarette smoking. The same outcome measured in different ways, for example, self-reported versus biochemically validated smoking, and so on and so forth. And when these different measures point in the same direction, we call this coherence. It makes your findings more credible. Again, it's about getting you educated while you're doing this. It's not just about getting results. So let's select some of the variables that qualify as our secondary outcomes. Here, we're going to select any combustible tobacco, no RYO. We're going to select any combustible with RYO, any tobacco, no RYO, any tobacco with RYO. Let's select current cigarettes, ever use of roll your own cigarettes, and then current roll your own cigarettes, and where is ever roll your own cigarettes? Did we select that? Okay, ever roll your own. So we have current cigarettes and ever. Do we have ever cigarette? Let's see. Oh, you know what? Let's keep it simple by just using only the current. So let's unselect this so that we keep it nice, short and sweet. So let's review. We have 5 variables: any combustible tobacco with RYO. We have any tobacco, no RYO, any tobacco with RYO, current cigarettes, and current roll your own. So those are our secondary outcomes. So far, so good. Then choose the main predictor or exposure variable for your analysis. Right. Now, even if your analysis is exploratory, it makes sense to structure your analysis in the causal framework, where we have an exposure leading to an outcome that allows us to identify confounders, right? It's easier to conceptualize your study that way. In this study, which variable do you think is a main predictor variable? What do you think? It's dwelling, rural or urban. That's a major variable that we care about, right? Is that that's an unordered categorical variable? And then lastly, it says choose all your demographic variables that I care about. So let's select them. We have age, which is a categorical variable. We have gender. We have grade level. We have sex. Let's see. Oh, sorry, grade. Okay, sorry, it's there already. I think there's one. Oh, we didn't record grade race, did we?
No, you didn't.
Oh, geez. Okay. Let me quickly record race. That's a very important variable, race M. So let's record it. One is white from the code book. One is white, 2 is black. Again, from a code book. I'm not just pulling from my mind. So 2 is black. 3 is Hispanic. And we're going to combine 4, 5, 6, and 7 into one category as other. Let's just merge this and call this other. And let's call this race 4.
I have a quick question.
Yes.
For the data I'm doing, let's say I'm doing, there was, yesterday you were showing some place that had, study design where you would say if you're doing a randomized control trial, or if you're going to, where is that so that I can specify? Because the data that I have here is a clinical, like kind of a.
Okay. No, that one was just to help come up with the concept proposal.
Oh, okay, okay,
yeah.
okay. So if you want to do that kind of analysis, are you able to do it through the platform?
Yeah, yeah.
Well, how do you specify that?
So you have the, so maybe when we go over this, maybe that will
Okay.
help.
Okay. Yeah, because I know in traditional R or SAS, you have to convert the data to a long format
Mm-hmm.
where you have all the,
Yeah.
yes, and then before you do the analysis, but then here, I was curious on how
Okay.
to do that, but
Yeah. Then we want to go over some of those
okay,
estimate functions. Yeah. So we have selected our primary outcome, our secondary outcomes, our predictor. Now we're selecting our demographics. So we have gender, we have grade, we have race.
sorry to take you back a little bit.
No worries at all.
So for the other issue is that because the data that I have is still in a white format, and let's say you're looking for change in carries or change in something,
Mhm.
right? So there's a column for baseline.
Yeah.
There's a column for 6 months, 12 months, 14 months. So when you're trying to select this variable, you just select baseline, but then there's no option for outcome for you to select
Okay.
the other
So you
one.
have to reshape the data.
Okay.
You have to reshape from now
White
when you
from-
collect the data from the platform, it automatically asks you what format you are reshaping. That you want to
Oh.
read it in long, because the platform allows for longitudinal data too.
Okay.
Where as you collect data, you have, like it's collected and and stacked together. So you can then choose whether you want to read it wide, or where you could have like 10 versions of the outcome, one per wave,
Mhm.
or whether you want to stack them in a long format. So where you have one single variable.
So you can do that in data processing now.
Yeah. So right now, I think we only allow that option for when you are collected your data from a platform like on a survey.
Okay.
Longitudinal data. But that's a feature we can definitely add generally on data processing as well, so that you can easily do that reshape from long to wide. Yeah, the problem with just using external data to do that reshape is that sometimes data comes in very poor quality. Many columns missing, and you can never trust the quality of the data that you are trying to reshape.
Okay.
So that's one of the reasons why we left it out now, because the data could come in qualities that you can never assure, and whatever is on the platform, we ultimately have to assure that it's completely fine.
Okay.
But we will definitely add that as for even data sets that are external.
Question.
Yes, yeah.
For my weight that I wanna take out the missing,
Okay.
doesn't allow me.
So you can go to data processing. That's not an issue of recode. It's just an issue of replace.
Oh, okay.
So what you need is to find and replace. So find and replace. In this case, you select the variable you want to find. You are saying find what? Find missing. Replace with what? Replace with the value, whatever you want to replace.
0.
exactly, yeah, in this case. So, you know, so there are different operations because some operations have solved with specific tools. So in that case, that's not a case of a code because they're just trying to replace a specific value.
Okay, I see.
All right.
So if you want to do analysis with complete cases only, what do you do?
You can
Or
choose
remove all
to,
the missing from your data.
yeah, you can choose to drop the responses. We have an operation that has to do with delete records.
Okay.
So, but yeah, that's the feature you could use to do that.
Okay.
Any questions? All right, let's.
To make new variables out of a couple of existing ones. Like, for example, I'm doing DNFT and I do have a variable for each two. Now to make a new variable that records a DNFT, there's a DN and
Yeah. So I'm actually writing a manual for how to step-by-step guide on how to so that we can finish this project
yeah.
on how to create the measure of enhance because the measures of periodontitis, for example, used in US federal report seems to be like something that comes from a black box, which nobody knows how to generate them. Maybe some, it has always been one guy who somehow has the knowledge of this and nobody knows how to generate those variables. So we're creating a step-by-step guide on how you can do that with the Kairos platform. So share that report when it's ready.
Yeah, so if you want to create a new variable, it's essentially recoding, right? The ones that you have already and set it in a different name. But
Yeah, I was wondering if it's done. I know it's done, for example, on R, it's very easy, but on the platform,
Yes.
it's very.
yes, so you use the recode. So if you see that variable that you like,
Mhm.
you recode, so you go to that, if you want to create what's it called? Is it composite?
Mm-hmm.
Yeah, composite
Variable. Yeah.
variable. There's a place under if you see data processing, you go combine data set. Yes. You go to combine data set. No, not combine data set. Is it create composite variable?
Composite team.
Create composite variable is the one in the middle.
I know
Yeah.
that category,
Yeah,
so I
under
need to
that,
put them
yeah.
order.
Create composite variable using
Doesn't matter.
so
Did it make sense? But I know
so
they're in
you
order.
now
Yeah.
select
Mhm.
when you select the variables that you want, then you want to create composite data set.
Okay, so we're selecting our secondary variables now. We have to go and create the measure for race. So current cigarettes and current roll your own. All right, so these are our secondary outcomes. Any combustible, no RYO. Any combustible with RYO. Any tobacco, no RYO. Any tobacco with RYO. Current cigarettes and current roll your own, right? And then again, our predictor was rural or dwelling, called it. And then the main demographic variables were race, which is unordered categorical. We had age cat, gender, and grade. And so these are all. Is it possible for the automated system to know the difference between an ordered versus an unordered variable? Or do you think that is deeply contextual? It's contextual, yeah. There's no way you would know. So that's why things that the system cannot know automatically, you have to now tell it. But you don't have to tell it what it already knows. So that's the philosophy in engineering. If it's something it can know, well, why should it rely on you to tell it? But if it's something that it does not know, it can't just guess it. You have to supply the information. That's why on some things, you have to supply the information. So this is another categorical variable and this. So now we have selected all our variables, right? So now the platform will suggest analysis for us based on the things we have selected. So all we now to do is click on suggest analysis. All right. Now the platform has suggested analysis. It says your paper will have 4 tables: table 1, table 2, table 3, table 4. And table 1, it says it should be characteristics of a study population. And here's the justification that's provided. It says the distribution of categorical variables will be summarized as percentages, while any numeric variables, if present, will be summarized as means with standard deviations. Again, remember that we have already set our analysis to survey mode. Any analysis done at this point will automatically account for the complex design. You don't have to do anything manually at this point. Table 2 says overall and stratified prevalence estimates. Again, it provides, justification. So all this at this point, remember, we say analysis is really just one click. And when we mean one click, we mean simply just click on this button. Now, in regression analysis, it's very important as, researchers for us to consider issues of confounding and all of that. To do that, you come to variable selection diagnostics because you have selected these variables, right? But the question is, are they confounders? Did you consider other variables? So when you click view variable selection diagnostics, the platform analyzes for you confounding as well as collinearity automatically. So if you click on, for example, confounding variables, it takes those variables and then runs tests for confounding. And operationally, test for confounding is fairly straightforward. A variable that is independently associated with exposure and with the outcome and does not lie on the causal pathway. Those are things that we can mathematically calculate, right? So it says that the following potential confounders were independently associated with both the exposure and outcome at this threshold, 0.2. You can obviously change the threshold. You can say, oh, I want to change the threshold to something else, like let's say 0.5, right? And at that threshold, the platform will assess and show you whether or not, there's a difference in the confounders. You can also look at the results from bivariate analysis that informed that decision. So the platform takes the variables that you've supplied. It obviously knows a specific kind of test that should be done for each variable. It performs those tests independently and tells you the outputs. So confounding involves 2 tests: test for association with exposure, test for association with the outcome. So this is test for association with the outcome. Here, these are the variables we had. It knows that this requires chi-square test of independence. It ran all of those tests, and
Based on 0.5.
based on, so it ran all of them and gave it a p-value. The determination of confounding will now be based on that threshold and say, at this threshold, here are the variables that were associated with both the exposure and the outcome at that threshold.
The threshold is based on what?
Based on what you selected.
Is it based on the p-value?
Yeah, so exactly. So if you set a threshold of 0.2, it will say which p-values here
Okay.
meet that threshold for both,
0.2.
exactly, for the exposure and the outcome. So this is here the test for so here you see that race, it said only race was identified as a confounder. Race is signally associated with the exposure, with the outcome here. The p-value is smaller than 0.01, right? There are several other variables that are significant here. But when we go to this part B, none of them are significant except race. So that is why only race was flagged as a confounder at this threshold, right? These are things that you ought to know and you ought to do, but again, these are things that can easily be automated, and so the platform does all of those things for you.
So if the p-value, if it is not significant, because this is sometimes twists my head, it is not significant, so there is no significant difference between this and this. But if it's significant, there is a significant difference between the 2 variables, so it should be not a confounder.
So a confounder has to be associated with exposure independently, and then it also has to be associated with the outcome.
Yes.
So the p-value for both must be smaller than the threshold you have specified.
Yes.
So race,
Then is significant.
yes, if
Okay.
it's smaller than significant.
Okay. So any one that is significant is not a is a confounder.
But significant with both with exposure and with the outcome.
Oh, okay. Okay, that's what it does.
That's what it
Okay,
does, yeah.
Okay.
So the platform runs the tests it runs the test associations with both all of the exposure with the exposure for all the potential variables and with the outcome based on the classic definition of the
Okay, that's why
confounder.
you have the stage step. Part one and part
Exactly,
two. Okay,
exactly. Part one is
for the outcome.
for the outcome and test with the exposure.
Okay,
It has to be both of them.
okay. Now I get it.
Yeah, so you have a whole lot of variables here. All of them are associated with the outcome, but only one is associated with the exposure. So based on the classic definition of confounding epidemiology, only one variable meets the designation. Now, if you were to do this manually, it's going to take you a couple of hours, really, or days, as the case might be. But yeah, go ahead. Yes.
I might have missed it. You said like some categories, like it doesn't matter the order, which is age, but what about poverty line, mother's education? Do
Well-
I put them unordered?
You should just select what the variable truly is. If it's ordered, select ordered. If it's unordered, there's no way for any other human being to know except you. So if you know that this variable is ordered, then just select ordered.
Okay.
Because you're not losing anything.
Because you told me like when I thought the age of the teenager.
Oh, so you're blaming me now.
No, I was like,
I'm just
no,
joking.
I was thinking like it doesn't matter,
No,
but there is order in the age, but I don't know like
if there's order in the groups, then just select ordered. But it doesn't matter if it's not the outcome. Because if it's a categorical variable and a categorical variable, the test will be a chi-square test regardless.
yeah.
But then we also have chi-square test for trend. So the bottom line is just select whatever the truth is for your variable. I
For age group, there could be other. Of course, but if it's for age, regular age, is continuous. So that the argument of order, no order, is no longer in play. Do you get what? Do you get
Yeah.
that? Yeah.
All right. So now the platform has suggested that, okay, for this manuscript, yeah, you're going to have 4 tables. So that removes the barrier to knowledge. A person who has never written a manuscript will have a hard time knowing that, oh, this is how I should structure my manuscript. I should have table. No, they have no idea about that. So the question is, how do we, if somebody already knows the variable that they want and knows that this is what they want, yeah, then we shouldn't make them go through hoops and hoops. That the whole point of education is to meet people where they are. So it's like, okay, just tell me what you know, and we'll get you to where you need to be. So here, all you need to do is run this analysis, right? So all you need to do is just click, estimate. Platform takes that information and runs the analysis that is required. And now you have the results here. So this is the demographic. Again, this analysis are weighted in this case. We always weight the percentages, whereas the sample sizes are always unweighted, right? So it runs it. This is the population characteristics. It creates a plot for the for the characteristic of group of that was selected in the analysis. The platform also writes out the results for you in terms of what was observed. It writes out the methodology, it writes out the results. So here, for example, dominant share consisted of following groups by grade, high school, 55.9% were high school. By race, the largest segment was white, 52.6%, so on and so forth, right? Now, all I need to do now is to push these results to my manuscript. So let's do that. Let's push the results to, let's create a new manuscript, academic manuscript. Okay.
I think are you all following the push parts?
Okay.
Okay, so that's the thing.
All right. So
No, like I'm fine. I know like it's simple and I'm following everything, but I'm gonna wait until you finish.
Okay.
I have a question because
Okay.
it's asking me.
Okay.
after
Can you
choose.
please go back to before the push?
okay, of course, definitely. Yeah. So let's go back. Let's cancel.
So here, okay, the result is generated. We're following up to this level, right?
So we had the tables and we had the plots created from it, the text, and the metadata. The metadata is every information. Meta means behind. So the metadata means the data behind the data, right? So this is the kind of the analysis you did, the you use the entire data set, and this is the date that the date and timestamp of the operation, right? So now the actions are you might want to rerun with a different specification. You might want to download the table. You might want to push the results. Are we all clear here?
Yeah.
So push. If you push, you have a list of all the manuscripts that you have in your account currently. So you can push your current manuscript or you can create a new one. In this case, we are writing a new manuscript from scratch. So we're going to create a new document.
So where do you have the option of pushing to already existing manuscript?
You just select, these are the manuscripts I have here.
Okay.
So I can just select the only one I want and push through it.
Okay.
I can also choose what I want to push. Do I want to push the tables, figure? We had generated tables, figure, text. Do you want all of that? Do you just want the text only? Do you want the figure only? Do you want, you can check the box or uncheck. In this case, I want to push everything. Does that make sense?
Yeah.
So if I want to create a new manuscript, I click here. I can upload a new manuscript and push through it. Or I can, in this case, I want to create a brand new manuscript and push through it. So I click on academic manuscript and I click on start writing. I have to supply the title. So I'm going to call this title evaluating the impact of including roll your own cigarettes in case definitions of current any tobacco and current any combustible tobacco use. Yeah, this is so long. Among US adolescents. Right, that's my title. How does adding RYO change the prevalence of current any tobacco use and current any smokeless tobacco use? Current any tobacco and current any combustible. Then I have to provide a title, an aim. I can type it myself or I can ask AI to generate an aim for me. Those are the only parts we use AI. None of what we just did here involves AI. None of the analysis, nothing involves AI because obviously AI cannot, as of now, AI cannot deliver, cannot be 100% correct 100% of the time. So we can't allow that. But for minor things like, it suggests an aim. Yeah, AI can definitely be used there. So I'm just going to select these 3 aims. And now I can start writing. So this is the topic we just created. It has created a project and selected it for us. Now all we have to do is push. Does that make sense? So I'm going to push. So it has pushed the results now to a manuscript. We can go and view the manuscript now, or we can just continue. We can just push everything and go and look at it. I just prefer doing everything and just going once and looking at that. So instead of viewing this, I'm going to close this and then go back to the analysis. But if I chose to go to the manuscript, the whole analysis will go with me. I mean, what's the point of an ecosystem where I have to go back and forth, right? The system is designed to be seamless in such that there's a very solid handshake between all parts of the system very coherently, right? So it's like you are in Microsoft Word, but your analysis is right there in the, that's how we engineered it so that it's seamless and goes with you. All right, so now let's so we've finished this analysis. So now that we've run this, it's changed to view history because it's no longer, there's no need for us to run it anymore. As opposed to this one where it says run because we've not run it yet. So if we click on run, it will load this. This is just giving you information to take note of. If you have a variable that is not in the right format, it's going to ask you to recode. It's not going to ask you to go back and select it, so you can recode on the fly. But in this case, this variable is not even something we want to, let's remove it. We don't need it for our analysis. So here we're trying to estimate prevalence of all of these products stratified by these variables. Make sense? you can choose the preferences here, whether you number of decimal places you want, let's say one decimal place, whether you want to suppress unreliable estimates. Generally, we use the relative standard error to measure estimates that are reliable or not. The standard in federal reports is suppress estimates with a relative standard error of 30% or higher, right? You don't have to, in the good old days, we had to go and you do your analysis and then you go and calculate the relative standard error.
Yeah.
And then you now come back and it's like, really? No. Life can be much simpler. So, and that's the whole point of chi-square is how do you, all of this, things that people may not even know about. People may not know that, they have suppressed estimates that are not reliable, right? And so how do we meet people where they are and make sure that the quality of science actually improves? Because that's what eventually results from this. There's better conduct of science. So you can choose to suppress unreliable estimates. If you do, it will ask you what's the threshold you wish to, and it educates you that the relative standard error is calculated as, again, there's a lot of education going on, right? Relative standard error is calculated as standard error divided by the proportion, and that measures estimate reliability. RSC values above 30% indicate imprecise estimates. So you're not there to wonder, what does this mean? There's education going on there. So in this case, and then the question is, how do you want to report estimates? Do you want to report as percentages with 95% confidence intervals, or do you want to report as percentages with standard errors? The choice is up to you, So here we've selected one decimal place and this, so you apply, and that comes from the reduce the context window, the preferences. You can also in federal reports like this, we typically calculate estimated number of users. Like you have, like any tobacco use 5.28 million users. People imagine, this is always a mystery to people how these numbers come about. They typically imagine that what we're doing is we take the percentage and then we multiply by the census number. That's what people imagine, that the numbers are calculated. No, that's not how they are calculated. They're calculated from the weight. So if you calculate them that way, you did it wrong. They're wrong. They must be calculated from the weight. So if you want to calculate them, then you say also compute weighted population counts. You check that box and the platform will calculate it for you automatically from the weight correctly as it's supposed to be done, right? So here, we just want the prevalence estimate. So here we can then click on estimate. So the platform has finished the estimates. Again, the analyses are all rendered in a ready to publish table. You have the prevalence for all the different tobacco products here, any combustible, no RYO, and so on and so forth. And again, you have the plots, you have a text generated, and the metadata as usual. Again, we can push to the manuscript. So let's do that again. And then when we're done, we can now go to our manuscript and see how that has formed. So let's push the results to the same manuscript. Now we don't have to create a new manuscript because we're pushing to the same document. So push. Okay, let's push the content. Again, it's asking us, do you want to go and view it now? No. Let's just finish the other one. So remember what I said earlier, that the manuscript writing is easy. We're just clicking buttons. The hard work was creating the variables we were creating. The design and all of those things. That's the hard work. Any other thing is just, click. You don't have to write it. The platform already knows you click this and this. It knows it's weighted. So you don't have to tell it, you don't have to now start saying we weighted the data. Of course, the platform knows you weighted the data. It was there when you were selecting weights, right? So it writes out all of that for you. And then the next is adjusted odds ratios calculated in a multinomial logistic regression. So here, our outcome had 4 categories, right? We may not know that we're supposed to do a multinomial regression, but the platform knows, like, okay, well, you have multiple categories which are not ordered. Well, you should absolutely do a multinomial regression, right? that solves the barrier to knowledge. You know, we asked earlier what regression, and we could not answer the question. Well, the platform has answered the question for us and has set it up for us. So now all we need to do is, and you can say, I don't want this regression. It gives you alternatives. You can say alternative models. You can select from any of these alternatives and run them. And all the alternative provider are, you know, justifiable too. But should you want to run this, you click on
But
again.
usually it's just the best one.
Yeah, of course, it suggests the best one statistically.
Yeah.
The platform also, so it has loaded the multinomial regression. This is the outcome variable we selected. We have to select our reference group. When you're running a multinomial regression, the outcome has a reference group too. So we select a reference group for this. And then these are the predictors we selected. The platform has automatically selected a reference group for us based on what it thinks is best for us. And it does that based on sample size, right? For robustness of an analysis. It automatically selects that, well, you can change your mind, but we think that this should be your reference groups. We think that for race, you should use white. We think that for age cat, you should use this and this, right? I mean, you can change, it's your study. You know, it's absolutely your study, so you can do whatever you want. You can say, well, you've suggested early teens, but I think that I will just rather use the youngest age group so that it makes sense. So I'm going to overrule his decision there and change. So this is why, you know, it's not just, you have to understand what you're doing so that you can change its recommendation to whatever you want. And then these other ones, I'm fine with them. And so here, the model optimization allows you to see whether the model is well fit and collinearity and confounding, if you want to explore all of that, right? And now we can.
So the model says multinomial logistic. Do you agree with?
Yeah,
What makes you agree with?
because the categories we just talked about.
Okay.
Yeah.
Okay.
And we could do like also if we want to overpower, like we could, if we want to think like another analysis better, we could.
So that's why I was like, so I'll be sure you're not following the model blindly or based on their suggestion. Do you actually agree with the platform? Is the suggestion the right suggestion that you feel is best for your data, right? Or is there a confusion there, or maybe things are not? So you have to also triple check that and make sure you choose the right thing. But in this case, it's actually right because the SIG RYO is multi-categorical, like multiple category. So
Yeah, excellent. So here we have again our regression output. Again, we have for the plots. Of course, the plots for a multinomial regression are quite more advanced because you have a reference group for the outcome. And so you have reference groups for the predictors, but also reference for the outcome, which makes it quite interesting. And so again, all of this is visualized for you. And the text, again, as usual, plotted with the methodology, the results. So let's push this to the result, and let's now push results to the same paper. Now, this time around, let's go to that paper and let's see what it has been doing there. So this time, the analysis tray. So now we're going to click on view results. So this would now take us from analysis to the document. So it's now leaving analysis now. Oh, let me. Am I signing into the right account? So I think this was this. All right, so let's resolve these variables. And let's resolve the tables and figures. So as you see, each push of the result is a separate block of item. And the reason why that is the case is because whenever the order in which you push the items doesn't matter. if you remember, we said analysis is supposed to be univariate, bivariate, multivariable, that order. It doesn't matter the order in which you push it. The platform will, the content will crawl to where it's supposed to be and insert itself at the right place. So it doesn't matter whether you push the population characteristics last. It will crawl, literally crawl through the document to the top of the pile. So, and that's why here it says under construction. Like, don't worry about how it looks. Just trust the process. Right. So when you're done with everything, then you can clean your documents. But right now it's in blocks like this. So these are the results we've pushed so far. Right. So the methods and the results of the document are the most sensitive part. In both of these sections, the Kaisos platform uses zero AI in the construction. It's all about statistics has so many rules. There are thousands upon thousands of rules in epidemiology and statistics. And where we have a lot of rules, that's fertile ground for automation. We can easily automate where we have a lot of rules. And so we've taken advantage of all of those rules, because anytime you can say to somebody, follow these steps, here is the process. Well, that means it can be automated.
Yeah.
Yeah, so it's easy to build automation on anything that has rules. That is exactly what we've done here, right? So in those sections of manuscript, zero AI, it's all about rules-based automation. So when you're ready to clean your manuscripts, then, because you can then use this part here to clean it. Because the thing is, what does, for example, HCAT4 mean? We don't know what that means, right? It's not intuitive. So to resolve those issues, you come here and click on this part here. To polish your document. So click here. Now here, you have to supply the names and what they mean in simple English. So the platform will crawl through the document and replace all of them in context. Because now you have, this makes no meaning, right? This has no intuitive meaning.
Yeah.
But it will now have meaning when you do this cleaning. So that it now reads like a well put together manuscript. So let's do that. Let's see what that means. Dwelling means your let's say geographic location. Race means race ethnicity. So we'll finish with this and then we'll go and tackle the introduction, the discussion, and the rest of the manuscript. But this is the hardest part of manuscript. Well, age cat means age group. Gender means gender. Grade means grade level. Any combustible no arrival means current use of any combustible tobacco without including roll your own cigarettes. That's a mouthful, but it's what it is. Then this one, yeah. Then here, any tobacco, let's go to the front. Current use of any tobacco, let's delete the word combustible. Any tobacco without including roll your own cigarettes. Copy this. Oops. Then this is current cigarette smoking. This is current roll your own. And this is what are we going to call this now? This is sorry. No, these are the 4 groups we had.
Yeah. The four combination.
What is that for combination?
So I call it unique,
That's your outcome, the
unique group,
opposite.
yeah, unique groupings of, exclusive.
Combination.
So exclusive, it's not even necessarily exclusive per se.
It's a composite something.
So let's go with unique combinations of cigarettes and RYO use and roll your own cigarette use.
How would that read in the announcement?
We shall see in a minute, including exclusive groups. This is like a whole paragraph. So once we are done with those, we can click on submit. So it's going to take those terms and it's going to attempt to crawl through a document and replace them in context. So that, where it reads so and so, it will look at the terms, the interpretation that you just provided and give it meaning appropriately. So let's see what comes out. Yes.
Because you have
Okay.
told me to do something and I don't think it makes sense. When you tell me to collapse the groups, it will not make sense. For example, this is something transit, you have to if I collapse them,
Secondary
here it will
outcome.
be one. Exactly. For example, this will be one.
For
This will
just
collapse
this
together, yes?
Because I tried
But
to
this
go.
will be, this is, and this is S, here I'm missing the
Secondary.
M.
Yeah.
This will be a new one. So this will be
Whatever is the closest
this
to,
will-
Okay, so
I can't remember the topic, but whatever makes, what is the closest thing
This
there?
is the variable, this is
No,
the variable,
the
right?
HPV
Central,
cover, right?
lateral.
Plano,
Okay.
for example, yeah.
Okay. So what do you
And
want
my
to-
predictor,
want to
insurance
collapse.
status and
What I'm
sex.
doing is,
What do you
Then
want
I
to
input
collapse?
some
what you're
other
doing is to collapse this.
variables.
Okay.
But it doesn't make sense.
Okay.
Because this is one, this is two.
Okay.
The total here is three.
You don't have a variable like HPI
Yes.
awareness.
This is the DNFP score.
Yeah.
You don't have like a variable.
There is child well
Yeah.
visit,
Yeah.
If I collapse.
Okay.
but
the
I
D-
used it already as a
the
variable.
variable,
Okay.
As a
the D
proxy
state
how
will
the
be
household
given
doing with the general stuff.
So,
Mm.
oh,
And I
okay.
merged
So
them.
Okay. Let me think about that for a
So
second.
you mean
Okay.
if M is two, like the value of M is two.
No, M is missing.
Okay.
D is the K.
Okay, this is DMFT. Okay, D is the K. Okay.
So DM, my table score will be two, not just DNFT.
Yes, two.
Okay? Yeah. So I'll have to, if I collapse the groups, I will have one.
No, you would- that's not how it is. So, okay.
I will
Oh, you,
collapse.
oh, okay. So you
So it
mean
won't
like,
work.
okay, you mean like if you collapse both of them, it will now
To one
not be
variable.
one variable.
Mhm.
Okay.
If
so
I collapse, for example, upper arch versus lower arch, 10, as you said, will not work.
So you want to add. That's what you want to do. You want to add for each individual.
Yes.
Essentially.
Not only can you variable,
Right.
just DNFT.
Yes. So is this variable plus this variable plus this variable? Is there a thing like that where you want to add
Yeah.
values of
Fixed
each?
development.
Arithmetic means you can go to under processing. Yeah, there's means.
I'm trying to learn.
No, I'm just joking.
I know you're joking, but it's very funny.
Okay.
Arithmetic means.
Yeah, go to, let me go to, hold on a minute, let me show you. Let me switch to analysis so I can show you quickly. So you go to data processing under arithmetic transformations. You come to multiple variables. You select the variables you're interested in. Let's say these two variables. And you select the operator as plus.
But the variables are not numbers,
Yeah, what?
the letters.
The letter. So what do you want to do then?
I want to, if it's a D, it's an M. If it's certain letters, it counts it as one and put it in a new variable as a total number.
So if it's D and it's M, it should be DM or what?
D and
It should be one, so D, so
D
it
is
would what,
one.
D is one. So what she needs to do is that when she goes into the, each of the variables, we convert them to one. It's like, you want to put all the M's,
Yes,
you want to put
I
all,
will convert it into numerical and then make this to make,
yes,
convert it
so-
into numbers.
so what you can do is that if you go, if D is one, M is what? One. So all the variables, you just convert them to numerical. Right? So when you
And then
come
I do
here,
this and
yes,
that.
yeah,
Okay.
right?
I think it might be easier just to save it in the first, like in the code book from the beginning, from R while I'm merging
Yeah,
as a new variable and then put it here.
okay.
Because this is like 3 steps.
Yeah, it complicates it for you. If you
Yeah.
feel, if you feel it complicates it for you,
It
you
is.
can do, you do that, then it becomes easier for,
Mm.
to come.
But thank you for pointing out the arithmetic means I didn't have. Okay.
And it's a new platform for you, so yeah, you're not expected to know everything on it today. All right. Now let's quickly walk through. So there are many ways to collapse things. Let me quickly walk you through this environment quickly. There is a comment which allows you to communicate with your collaborators. There is a citation which allows you to, we'll come back to this in a minute. So let me just close this for now. We'll go to that last. Navigate allows you to look at the document you have and combine elements if you so desire. So for example, if I want to combine all of these methods, whatever, you select them and you combine, as the case might be. You have make visible, you have, mix up headers, you have, you can essentially do whatever you want to do, in that pane. You can also choose to use style. Style allows you to change things like the font type, the spacing of character of letters. If you want to have a title banner, so let me remove this thing here so that we can see clearly. If you want to have a title banner, which is something at the top, like let's add a title banner quickly so we can see what it looks like. So that allows you to, if you want, for example, add a logo, to your documents, you can add elements, you can type texts, elements like, header, this is my document. This is not, of course, this would not be appropriate for a manuscript, but if you have, not everything's a manuscript, obviously, right? This is my document. You can, increase the font size to wherever you want, move the location, place it wherever you want. You can add other elements like change cover. Let's see. You can change the cover. You can add other elements like the logos and all of that. So, but that's where you can also hide it, obviously. So that's what style does. Language allows you to translate text, to expand or contract text. These are obviously AI features. Check allows you to check AI activity. If you want to check whether AI has been used in specific sections of a manuscript, then this platform, we don't believe in hiding AI as if it's a dirty little secret. No, it's just a tool. So where AI has been used in any part of a platform, it will show that AI has been used here. So for now, AI has not been used in any part of a platform so far, in our manuscript so far. So that's why you see AI not used, AI not used. The moment we use any AI, it's going to show in that section that AI has been used.
It will acknowledge it at the end.
Yes, it automatically load an AI user statement, yes.
Oh.
So that way it's done ethically. There's nothing wrong with AI. It's just making sure that it's ethically used. So that's the check there. You can also use this part for your pre-peer review. If you have a manuscript and you want to get feedback on its state, the platform does that pre-peer review for you. Versioning of a document so that if you want to back up. So far, the document we've had, it's created 2 updates for us. Whenever you have a massive change to a document, create a backup. If I add a co-author, it's going to create a backup automatically. In case the guy came and scattered my whole work and I want to revert back to the or the version it was before they came on board. Then handwrite. So those allow you to do things. If you want to add citations, you can all add them directly from a platform. So you have integration with PubMed so that you can you don't have to exit the platform, go to PubMed, look for papers on PubMed. Because imagine how, the way it's structured is that you have to go to PubMed, get citations, download them, import them. It's like, geez, really? Like that's a lot of work, So you can search directly from for your work here, right? Who wants to search? Let's search for your publications. Who has published here? So you can check for show you that the number of papers you expect to see. So you can see that it reflects accurately here. But yeah, it searches from PubMed, European PubMed, Web of Science, and all of that, so that everything is here. So and to cite, you simply cite individual papers, or you can select a bunch of them and cite. So let's say I want to cite these 2 papers. I can just click on cite. And the platform would process and cite in the place that you have selected. The default citation style is, AMA, but you can change the citation style to any format at all. Of course, as you have citations added here in the text, you also have references. What's the difference between citations and references?
The whole thing.
So these are references.
Yeah.
At the end, at the top,
Citation, which is
citations
in text.
in text, exactly, yes. So for each citation, so you have 2 citations, and so you have 2 references here. Take note that when this is the descriptive analysis we did. The platform doesn't just report descriptive analysis. As it was sending the results from the prevalence estimates, let me reduce this window so we can see clearly. So this is the unpolished document. So we've kept it unpolished so that we can just analyze it. So
How will make the changes?
I butted it.
Okay, cool.
So we can just look at and look at it in a raw form. So this is the text here. The variables are highlighted in green. For every analysis, the platform automatically tracks. Oops. Let me undo that. It's quite sensitive because it allows you to pull. You can literally drag into boxes if you want to manually do it yourself. So the platform tracks the number of respondents, for each analysis done. So here, for example, it says, as shown in table 2 and figure 2, prevalence in the study population was as follows by outcome. End tobacco use 13.9, end tobacco no RYO 13.6. So any tobacco, any combustible with RYO, right? So let's look at this first of all. Any tobacco with RYO 13.9, any tobacco no RYO 13.6. What can you say about that and the original hypothesis?
They're not different.
Yeah, so let's look at this. Any combustible with RYO 9.2, any combustible no RYO 8.8. What do you say?
No difference in the prevalence between the comparative groups.
Well, we can't say there's no difference because we didn't test for that, right?
Yeah.
This is just giving overall estimates. But remember we said 19.0, 19.1, but if the prevalence of any combustible tobacco use is 9.2, then we should report as 9.2 and not 8.8. Do you understand my argument? So from this, should you report RYO or not? What will your argument be? Going back to our original question. Any combustible with RYO 9.2, without RYO 8.8, will you argue that the difference between 8.8 and 9.2 is trivial? Because that's the original question we set to answer, right? So it might seem small to you, but in terms of the number of large national survey, that translates to a lot of people. But just tying it back to what our original question was, right? Differences in outcomes, were statistically significant within subgroups of age, dwelling, grade, gender, and race. So remember that when we're doing the overall prevalence, we never specified statistical testing, but the platform does automatically in the background. So there's no point reporting results that are meaningless. So it reports and says, for example, prevalence of any combustible no-RIO varied as follows. By age cat, that's 22.9 among group young adults 18 plus, versus 2.3 among this group preteens 9 to 12 years old. The chi-square test, yields, a statistic of 752 with a p-value of less than 0.01, right? So the platform performs all of those tests in the background. Of course, these were weighted data. All of these things automatically account for the weighting, right? And so that's how it it presents the results. So again, remember I said univariate, bivariate, multivariable. So you can see univariate, the platform provides the results here first, the univariate, the population characteristics. That's what we have here. Then the bivariate is presented next. Then multivariable presented last. 1, 2, 3. One variable, two variable, multivariable, right? That's the gold standard for writing in science. And so now the platform has now done the work, the heavy lifting for us in terms of the methods and the results. Now we have to develop the introduction and the methods. Well, the methods have already been developed. We'll have to develop the introduction and the rest. So let's see how that happens. So here you click on generate introduction. Now, there are two options available to you. You have an AI first or human first approach. An AI first is, well, let the AI take a first stab at it, and then I'm going to review and make corrections to my taste. That's what that first option is saying. The second first is a human first approach, which says, well, you tell us what you want, and then we will take all your ideas and have AI polish them up. There's also the third option. You can choose to put off AI across the whole platform. It's not an AI platform. You can work without AI.
Yeah.
So should you choose to put off all of AI, obviously this AI first option goes out of the window. But you can still put your input, and the platform will now take them and structure them for you and say, okay, now you develop this point yourself. Right? So whether or not you want to use AI is up to you. So here, if I wanted to skip manual input and auto-generate with AI, I click that button. So this is an AI first approach. The platform would then take the context for the work and generate content. So it has done this already, right? So this is what it has generated. So let's look at what it has generated and let's see whether it makes sense. So it says, understand the impact of including roll your own cigarettes in current any tobacco and current any combustible use is crucial due to its wide-ranging effects on society, health, and community well-being. The use of roll your own cigarettes have significant implications for individual outcomes, such as health, mental well-being, and behavior, and so on and so forth. It talks about additionally, the use of roll your own cigarettes may pose economic costs, such as direct medical expenses and productivity losses. And so it says it's essential to consider disparities and barriers faced by disadvantaged populations, blah, blah, blah. Next, it talks about previous studies on RIO cigarettes have revealed several key findings. It discusses some findings, which it's your job to edit carefully. But then it talks about the gaps that exist in knowledge, that there is lack of data on the topic, which may involve examining the prevalence of this among, accounting for the gaps we've mentioned. And so again, this is not in the slightest meant for you to take and go. This is meant to be a first draft for you to now say, okay, does this make sense? How am I going to edit it, right? So this is the AI first approach that says, well, AI should take a first stab at it, because some people cannot. We're all different in the way we write.
Yeah.
Some people are literally unable to come up with the first draft of anything, not even to save their lives. So this says, well, let the AI create the first draft for me, and then I can edit. But and some people are really good at editing, right? And then they can now take that document and what they have at the end may be completely different from what they had at the start. But at least this gave them the scaffold to build upon. So that's one option. Let's clear this now and try again with now a human first approach. The human first approach says, well, it's your job to now tell us why is this important. So it's been arranged in topic areas. Why is this important? What do we know about this topic? And what's the gap, right? Those three. In each area, you're supposed to pick some issues and select some, and put a sentence or two on that answer. So it's designed like a form.
Framework.
Exactly. Everybody can fill a form. Nobody has a problem filling a form. So that's how it's designed. Like just pick 4 or 5 items and fill them out based on your own understanding. So I can say health and mortality, and then now I can pick which of those areas I have to select, right? So here I can say lives lost. I can say, and then type what I'm saying. Roll your own cigarettes. Cigarette smoking. It doesn't have to be fancy. It can be anything. I'm going to put it in the most casual way possible. It's dangerous as it often contains many harmful chemicals. I'm trying to make it as clear as possible. Which can damage people's health. So I'm saying, okay, this is one area where I think the topic is important, right? Under life and kill people. All right, that's one area. Then let's look at other areas. We'll talk about social determinants and equity. Maybe we can say health equity and disparities. We can say the use of roll your own cigarettes is higher among poor people. And those of, again, you put this and then later on when you're done, you can now add your citations and all of that. Low socioeconomic status. Well, what's poor and what's low socioeconomic status? All right, so I've put 2 items here: lives lost, health equity. Again, my option was select 1 to 5. I can stop here if I want. I can add more if I want, right? It's up to you. But the point is that you are the one supplying it may be harder for you to just sit down and start writing, but here you are being prompted with key areas that you can just select and write. And then environmental and global health, I can say pollution, smoke from roll your own cigarettes, causes air pollution, and litter, right? Again, they don't have to be profound truths, just simple statements. So next, I can go to what's known about this topic. And here, there are different frameworks that are provided for you to pick one. If you don't like it, you can just custom frame your own. You can just write whatever you want, right? But let's say I want to look at, let's say, problem, process, whatever. You can pick anyone that makes sense to you. And there's no right or wrong way. Just interpret it however you want to interpret it. But it just provides a structure for you to write. So again, the problem, what's the problem? The problem could be that,
Predominant among those low income.
yeah. They okay. So again, you just interpret however you want, but just write, Again, the goal is to unstuck you, right? People get stuck in the process. Just methodological approaches, the measurements of smoking prevalence has traditionally included only manufactured cigarettes. Then progress, under progress, I would say, while smoking prevalence has declined in recent years, but it is not clear again, it doesn't have to be fancy at all. The rates of, roll your own use. Right. Then I think I'm done with that. I can now go to the next, which is the gap, which is the last one. So this is the same framework that applies to all the other sections of a manuscript. Like it's like literally like a form. You pick answer the part, and the platform generates that. So gaps in knowledge, can select any of those gaps in knowledge. So here the gaps in knowledge are classified in different ones. Is it place-based gap? That means we have data for there, but not here. Or time-based gaps. We have data for then, but not now. Or outcome-based gaps. We have data for that outcome, but not this. So let's use that one. We have data for manufactured cigarettes, but not hand-rolled cigarettes. Also, we don't know how including hand-rolled cigarettes in any tobacco use measures affects prevalence. Again, you don't have to write an encyclopedia. Just to give put your thoughts coherently. Now I'm done. So now we can generate the introduction based on my own thoughts first.
Ask the question.
If you have chosen 2 articles from PubMed and Fieldwork, so you can customize the which we have seen in the second part. Can all the feeding, you can customize it?
Yeah, and
Why important? Second was the third was literature gap, second portion. So that customization can be done all the three, because we have selected from our literature and then we put it and jot it down.
yeah. And you absolutely don't have to use this feature. You're aware of that, right? You absolutely can just go here and type everything you want yourself. It's just meant to help you if you are stuck. But if you know what you want to write, you absolutely don't need to. My preferred way of writing is I just dictate. So I'll just come here and just type what I want to say, and then when I'm done, the system takes all of that information, and then that way, because I'm not looking at the content while it's being dictated. So that frees me from saying, geez, is this content, is this flowing well or not, right? I just talk. It takes the content, writes it down. My job is just to talk. His job is to take the content. And that way I'm freed from worrying about whether it's coherent. That's the FBR style of writing. So when I'm done, I just say, okay, done. And it types, and that might be your own style. It's like, we're all different. However you choose to write is up to you. So that's why it has, created, right? So you can then polish it however you want. So it's the tools are provided for you to use however you want. Like, people have different writing styles. So that's the same approach we will then use for the introduction, the rest of the manuscript, the conclusion, and every part of it that remains, right? The discussion, all of that is based on the exact same framework that we've discussed. And that's how you can now write. That's how the platform allows you to write a manuscript in a day. So do you think it's possible for you to write a manuscript in a day now?
in an hour.
You can, depends on who you are, right? You know, you can. But yeah, you
You have
literally,
the data ready.
yeah, you have a data ready. Yes, there's literally nothing stopping you from doing it.
But I also want to ask, like, when you say when you're writing, you should have good number of references. So if this will generate how many references?
You're the one generating the references yourself. You're the one reading. So when you if I, you know, for example, want to cite references, I mean, like it's your paper. Do you understand? You're the one inserting references. So it's like it's like writing a manuscript. No one can tell you that this is the number of references. If you want to have 500 references in your paper, sure, so be it.
So with this one that you just detected or detected or you just wrote or
Yeah.
will this platform cite that for you? Provide citation and
So
reference for it.
so I just dictated. I didn't even push it. So, but it will persist the content, but it's just your own spoken record. Like
Yes.
so there's no reference for it because it's just you are the one who will provide a reference because it doesn't know what that is.
Oh, okay.
But if you want references, you can go to the reference section and search PubMed or wherever you want. And so it's not doing your job for you.
Okay.
It's just making it easier for you to do your job,
Okay.
which is to
Because
set
there was
reference.
one you did yesterday that provided.
Oh, yes. So that is the concept proposal, the proposal.
Okay.
So yes. And here too, we actually had a feature, but we just removed it. We feel that already people think it's too easy. So you have to make them suffer a little. You know, so but essentially that because it's that same process. It takes the text that you have, parses it apart, and then creates queries, crawls across PubMed, looks for references for it, and inserts it.
Okay, is that what it does?
That's what we had it do, but we removed that feature.
Okay.
Now you just put your reference because then you have more questions to answer. Like, where is it getting references for?
Yeah.
So it's like, you know what, just go and look for the references yourself, and that is
Yeah,
yourself.
because the one you showed that if you allow AI to write for you, so that's the question. If you allow AI to write for you to provide you references, or you like for instance your introduction, do you go and search for the references of what the AI wrote to, you know,
So so ultimately AI never writes. You are the one writing from our perspective.
Mhm.
So whether it was the AI first approach or the you first approach, the writing is you're the author. The AI is supposed to help you generate the first draft, but we want to believe that you made radical changes to that document.
Mhm.
In fact, we strongly discourage you from using whatever AI you suggested and running with it. So
Okay.
having edited the document thoroughly, it's now your work and your responsibility to find the references.
Okay. So this is where it gets, that's where like my head flipped it the other way.
Okay.
Because normally it's easier, like if I'm writing something, I'll do some, okay, it's true. You generate some hypothesis when you're writing, you go search for literature for it, and then you reference whatever you find. Okay.
Yeah, because
That makes sense.
because the question is we believe that like management of references is an inherently human task. That is what now says that this is my work because I am now this is what my work rests upon. So it's not a question of whether it can be engineered. That's the easy part. Is whether it should. And we believe the answer is no. It's your work, even if the AI made the first tab, it's the work belongs to you. So by allowing you to go and look for the references, that forces you to read the document. And it forces you to now support your work or remove parts that can be supported.
Okay. So should we take some break? 10 minutes break, yes.
Need to stand up.
Yes. Let's take about 5 to 10 minutes, right? And then we'll come back. So we'll finish up.
Yes.
Okay.
Are we gonna be able to finish our own? Like, what's the plan on our own?
So for your own, yeah, we can
Because I don't wanna I wanna take advantage
of the
like doing it because
Yes,
I'm not
yes.
sure I'm stopped that I didn't do the analysis yet.
We didn't do the analysis. So what is holding you back from doing it? Is it-
Because it's asking me I need to choose another outcome and I'm not sure what outcome I choose.
Oh,
That's secondary outcome. So,
Because I cannot overpower that, right?
so that's a problem for you now, right?
Yeah.
So it should be optional, right?
Yeah, I think it should be
Okay.
optional.
Say no more, make it optional.
Thank you.
Yeah.
But like for the now, like
Yeah.
yeah,
For the now, you're not interested
you're
about
the
tomorrow.
archaeologist.
Yeah.
For now, the secondary and open it, let's see.
I'm
Yeah,
just
no, use the
thinking
bathroom
of-
quickly.
Yeah,
Yeah.
I'm just thinking, we're thinking like.
Sorry, people online, we're taking the 10 minute cancel already. This. All right. So let me show you the alternative. When that fails, you can always use I think this is where we are. Screen. And minimize this. So the philosophy of the platform is that for everything there should be backup, especially for things that rely on processes that are beyond our control, like integrations with OpenAI, for example. So in that case, there's always a way for you to execute an action. So in that case, you come to find and replace, and you see variable manager, right? So you see the variable, for example, grade. That's the variable in the data set. So you can now say replace with whatever it is we want to replace with. And then do you want to replace in all the 14 instances where that occurred, or do you want to replace one by one contextually? That allows you, it's a bit more manual, but it still allows you that opportunity to do it in the event that fails, right? So you still have a way of doing it. It should never be that there's only one way of doing something, such that when it fails, then you have no other recourse. So that's one option, you could use. What the clean does is it takes the content and pulls it together and cleans it. But you can also do it manually. I can say, okay, I want to collapse this. And that's why you have this. You can drag and drop and say, all right, merges sections, and then it merges. So that, that merge would have been accomplished by the clean process, but there's always a manual option for you to implement something as well. Because like I said, sometimes third-party systems just fail for whatever reason. Sometimes they peak hour usage or whatever, but that's some of the complexities of just especially AI integrations. Yeah, there's not always very predictable. So, but knowing those other options there can allow you to use them as the case might be. So, but yeah, the feedback from you, like that's one. Anything you would change about the system?
I suggested, like, for example, instead of forcing us to choose secondary outcome, opt out, like if I just want to stay with my only primary.
But that comes at a cost. It's also about trade-offs, right? Your manuscript ends up being shallow. The secondary outcomes add depth and coherence to your manuscript. So when you come out with a manuscript, when you opt out, allow people to opt, because the goal is how do you make people think deeply about epidemiologic study design? Causality is not just about, causality is established through coherence and consistency. That's what Hill's criteria.
Yeah.
That's exactly what the secondary outcomes allow you to do. To think through that carefully.
Yeah, but I agree with you, but I also see the point where
I agree perfectly. Like those are perfect arguments.
Yeah, because there's a study that we did, Journal of Public Health Dentistry that just called accepted. It's the major part of the study, the initial part of the study was trajectory analysis. So that's where our major analysis.
Mhm.
So whatever trajectory group membership that we found was now what we used as
Mhm.
the outcome variable for the other part of our
Yeah.
study when we just did the regular multivariable analysis. So in that case, we didn't need a secondary
outcome.
outcome
Definitely.
because we already did the
Yeah.
major part of the trajectory analysis and then we didn't need the secondary.
Yeah.
So that would have been a
Very valid arguments, very solid arguments, and I agree with you absolutely.
Yeah. So, but in definition of outcomes, yes, there should always be a secondary outcome. But
Yeah.
if we have the option of saying, okay, no, based on
My own
yes,
expertise and
yes,
context.
yes, context.
Exactly. I agree with you.
Every study it is asking for secondary outcome or like for in your case it asks for secondary outcome.
No, all of
The structure as a form.
Structure of the.
Combined. We actually,
Yeah, so that outcome is your primary outcome. So if you need a secondary outcome, is another outcome that you want to look at.
not any dental outcome is not really used to.
Yeah, so that becomes a problem, right? This is now becomes, for
Yeah.
example, a case for your own case as well. That you combine, yes, you combine only two dental outcomes exist, and you combine them to create an outcome, and then you don't have any other outcomes that you want to.
Yeah, but I would not combine them. I would have taken one, this outcome and the other outcome.
But you want to, but your research question is, what is your original research question?
Research question is the dental neglect.
Yes, so you combine two variables to define dental neglect. So for you, dental neglect is defined as having more than 2 days spending more than having not visited a dentist for more than 2 years and having more than 6 teeth missing, right? That's your definition of dental neglect.
But
So-
the title and research question I have explained both of them.
Yes, so both outcomes. So you derived your outcome, which is your primary outcome, which is dental neglect, by a combination of defining this order to this. But you can certainly make the other components, like, other smaller components as your secondary outcomes. So those other outcomes that you combine to create
Mhm.
the composite outcome, the dental neglect,
Individually.
you can make it individually as a secondary outcome. So that your model will still look at those individually as what are the predictors of missing more than 60, or what are the predictors of not visiting a dentist for more than 2 years. Do you understand what I mean?
That means I should not collapse them because
No.
no condition of composite. I have
That is not what I said. I said you can have 3 variables, as you have in your data set now. You have 3 variables. One is what?
dental visit.
Dental neglect. 2, dental visit. 3 is,
The composite.
yes. So you have the combination of the 2 as a variable, which is the neglect, right?
Okay,
You have the visits. You have the missing.
okay, sub.
Yes, so the missing, right, and the visit are your secondary outcomes. The neglect, which is a composite one, is your primary.
You have to create these two.
Though they already existed, we never deleted them. Right? When we created the other one,
Yeah.
we still retain them in your
Right,
data
right.
set. Yeah. So we never deleted them. So
And then one thing to point out is also if you have a document, manuscript you already had outside, let me just quickly, as a part we didn't show you, where you are uploading a document that is already created from external sources. So here you can whether it's academic or just general document. So if it's academic, then you proceed to upload the documents.
So what do you define by academic versus general document?
Is the document, will it be structured in like
Okay.
IMRAD? If not, if it's just a general a document that doesn't require this standard structure in a manuscript. So here you pull up the document. Let's say now you look for a manuscript. I can find the documents and manuscripts. Let me look for downloads. Ecological. So you upload documents and provide a title. Let me just provide a dummy title. And let me just, so provide the aims, and then you would provide an option for whether, because these options here are a function of what you selected. So here I selected my document is an academic manuscript, which suggests that it might have sections like introduction. So here, this option is saying, or to split the document for me. So split the introduction into introduction, the methods into methods, and so on. Manual split says, well, just ingest the document the way it is, and I will do the split myself. And then this one says, leave it as a free-flowing document. So if you see auto splits, what the platform does is that it takes the document and starts to process it. Oh, this is quite a different document entirely than I thought I uploaded. But anyway, if it were the document, it would take the document and parse it, if there are references. Because one challenge is always about how do I, if I submitted a paper to a journal and it was rejected, the pain of having to convert the references to another format. Let's say the original format was APA, and I've now submitted as, so in this case, this is a horrible example because there's nothing in here, but if it was a document with sections, it will now pass them into the sections, including the references, so that you can then seamlessly switch reference styles, as the case might be. So that's helpful because the current constraints is that even if let's say you use EndNote, well, you can't entirely switch the reference styles to another format unless you go back to that exact same software. Software that are not necessarily interoperable in terms of references. So that's always and that's why resubmitting work on that journal is always so hard. Because now you have to redo all the references to align with the new format. So this makes it easy for you to simply switch seamlessly, and all of those things, references are now imported into the Chi-Square citation library for you to then manage. So it becomes, you don't have to worry about the manual process of the mechanics of conversion. But anyway.
So, can you talk more? Do you have, I know, so does it allow for analysis of longitudinal data?
Yes. So, one of
these
are some of the features that we're rolling out. We're rolling a few models. The Cox regression, rolling out GE models, and so this will be in the next release. So allow, and definitely we'll also look at the reshape, long to wide and wide to long.
Yes, we should.
Yeah. So, but yeah, it's incremental releases, in versions. So that's so we look at things that constitute the largest pain point for the most people. I will tackle it at that point. Most people are not analyzing longitudinal data, Yeah. We figured, well, if you're collecting longitudinal data, then you're fine.
Yeah, this is not definitely for you.
Then you're most likely fine. Yeah, we plan to. Yeah, we are releasing that in the very next version. Because it's the way we structure is that it assumes no knowledge. So it's about not just the regression, but also automatically creating systems to test for the underlying assumptions. For example, if there's an assumption of proportional hazards, for example, how do you test that automatically? Assume that the user doesn't know what they're doing, that in fact they are completely clueless, and set up structures to make sure that things are done automatically, interpreted correctly. So it becomes a lot more harder than just writing a function, and it's a lot of quality assurance and testing and validations. So that's why it takes a lot of time to release one single feature. Because the user just clicks and the user is happy, like if only they knew the amount of work that went into it. the tiniest aspect of it. Yeah.
So, and then the other thing I have is for the multinomial, do you have plans of putting like special cases of, so like the multinomial, like is it baseline category? Is it cumulative logit? Is it, I know there are special cases of,
Yeah.
at their plan of, putting all those special, at least if somebody is doing those things, like you said,
Yeah.
the person, if you're thinking, this multinomial, and you're thinking cumulative logic, that means, yeah,
Yeah.
yeah, you're not, this is platform, it's probably for you, but you're way advanced and you're not knowledgeable about it, but I'm just curious.
Yeah, no, definitely, and that's why even they provide quite extensive options in the preferences, so that allows you to be able to select some specifications, that based on commonly used scenarios,
Okay.
and then for edge cases, that well, if you belong to the edge case community, then you're probably fine.
There's something too. Okay, so I think, is there any other, example? So we're going to finish up with the manuscript.
Yeah, so I was thinking we could just use the remaining time to answer any questions they might have
Yes,
about
and
their
then go
respective.
each person's work and
Yeah.
do like more, maybe you can help out more and with completing some of the analysis.
Yeah,
So
so
specific and writing. So Ashu, I can come. We can.
so any questions? You had a question, right?
Yeah,
Yeah, what?
we figured it out.
Oh, you figured it out. Okay,
The
awesome.
secondary outcome. We
Okay.
decided to do like, there was a question in the census, it's like how likely is the child will receive HPV vaccine in the 12 months, next 12 months.
Okay.
So we thought that might add,
So this forces you to think.
yeah, like might add like some
Yeah.
context depth to if the child have ever received or not.
Mhm.
And it's literate scale, so the missing or refuse to know, don't know, we just put them as missing and we didn't include them. But I did my logistic here and I have this question about the what I'm saying, reference group. How can I go back to the analysis?
So view history. So
The run.
what's the run analysis? So let's view history. Let's go back to, let's close this. Let's go to analysis history.
If I want to change the reference group.
Actions. Let's run.
I got insurance, so I wanna do compared to private, right? That's the.
Yeah.
Sex, reference male. Will child visit? I wanna compare the references, those who went, yes.
Okay.
Poverty, I feel like that's reasonable to put, because there is above poverty. More than 70K, there is above poverty, but less than, there is below poverty.
Yeah, I mean, it's not defensible, yes.
But what I wasn't sure is the age. I was thinking like either I go extreme youngest or oldest group.
That's fine too. That's perfectly reasonable.
And mother, I wanna compare the reference group is those who has college degree or more. Race, white, census regions. I feel like this is arbitrary. Should I do northeast, west, midwest, like, or should I do it based on sample size?
They're all valid. Like you need to have the theory. You need to have just studies. So you need to have the theory that you are actually. There must be a reason why, like, oh well, I think people in the Northeast are so and so. So
I think that's why I chose northeast because I think we have better health care
yeah, so
system.
that's really valid. So yeah, so there has, but yeah, those decisions are all yours.
And we're not gonna, do I allow or?
Depends on what you're trying to achieve. Robust standard errors will make the confidence intervals wider. So the question is, why do you want to allow them? So it's not a question of should I allow it? It's like, why may I want to standard?
What would be reason people allow to be wide?
So the instruction is provided here, right? So if you assume that they, for whatever reason, the standard, most variances are underestimated, and you know your sample. You know for whatever reason you think that the sample may not have been variance is not estimated correctly. It's smaller than you think. I mean,
Yeah,
in
we
most
do
cases,
have
I think
that.
that we should go around and multiply most variances by times 2.5. I think that's my opinion, because most people underestimate variance, right? So that gives you a lot of room for type 1 error, where you see results that are just don't really exist in nature because you've underestimated variance, and so your confidence intervals is narrow, and hence you come and declare significance. That's just one of the frameworks where we correct for that, to say make the estimates a bit more robust. Robust doesn't mean that, oh, you're going to get a nice result. It means that it's going to be more conservative. So everything there has to be driven by theory of your understanding of the context. So it's not something that you can ask somebody else. Should I do this? Like, oh, how am I supposed to know? It's your data, it's your study, it's your context. So your context drives it.
Okay.
Does that make sense?
Yeah, and so based on our earlier conversation about like the imputed, so we have really missing and low. So I feel like it's valid to use this case.
Yes. Possible.
So it's like, I would do. It's very late. It's usually like it's. Okay, this is the money. How about the, it's at the very, you know, we have a lot of experience. Some say still have it. See, people going to.
When you use the robust, yeah, there's a lot of math going on, because the calculation for that is a bit different. So you find that whenever you use robust standard errors, confidence intervals are wider. Some results that were significant may no longer be significant.
Now, I used to have like a lot of significant in the previous one. Now, not many p-value. None of them are significant.
So that's my point. What I'm trying to make. When you use this thing, you should be already aware of what to expect. That's your job, right? The job is to say, oh, I checked this box, so I should expect that. So even when you're teaching, right? If you're teaching students on how to use this, you let them know that, well, this is what this thing does. When you check this box, you are telling the system, inject a lot more variance into my result to account for the fact that I may not have accurately estimated variance, that actually underestimated variance. Make the variances bigger. By making the variances bigger, the confidence intervals become bigger. And of course, a lot of results that were significant will no longer be significant.
Yeah.
So it's beyond just checking the box, it's now your job to know that part. So even before the results come out, you should have a good idea of what to expect. You should expect that, okay, a lot of results that were significant will not be. So that you're not going to run around alarmed that, oh, why are the results no longer significant? It's because you are using robust estimates.
Okay, I see. And there was one thing that you mentioned earlier, before we run any analysis, it tells us about which one could be co-founder. How do we check that again?
When you are at the point of checking your regression, there's the that button that says optimization, model optimization. You can use that. It's always on every regression, it's there.
Can I go back and do it now or no?
Of course, you can go back and do it. Yes.
Is it from the same way here or?
Yeah. That purple button there. No. Up there. No, purple. Middle.
This one? Oh, okay.
So what you write, what you do?
So you check for.
Go back to the.
So you select the in general, we use the 0.2 threshold quite commonly as a threshold for assessing confounding. So that it is big enough to allow for qualitative confounding, so that variables can pass through, as opposed to using a more stringent cutoff.
I see.
Yeah. Does that make sense?
Yeah.
But of course, you can change the threshold, but if you should know why you're doing it. What happened to our picture downstairs?
We will do it after.
We don't,
But-
but it's,
He's leaving.
Yeah,
this one is the official.
okay. All right, thanks so much. You're welcome. Yeah, you're welcome, cheers.
All right, take care.
Bye.
Showing me now like the potential.
So you can now look at the bivariate, click that to see the detailed results of the bivariate analysis. Like what went into the actual output.
There was something talking about, yeah, so, we have to model. Fluently across each time. You have to. model
That is the
each one.
marginal.
Yes, so that is the average. That will check everything. This is it. So we have to model the retrofits to value. So we have to.
We wanted to, see, remember, go back to your model specification. See, NG is a. NG website,
Yeah. So how do you model? You're
So-
supposed to model the line.
So the first one, it shows me the association with the outcome.
Mhm. Yeah, because remember the definition of the confounder,
It's associated with both outcome.
exposure and
That's
outcome,
what I'm saying.
independently.
Can't you? Results.
So this helps you appreciate the definition of a confounder. So
Okay,
it's not enough for you to associate with one only. That's with both.
Yeah, for example, age is associated with the outcome, but not associated with the exposure, and
Exactly.
that's why they. didn't-
Exactly.
Yes, which is the marginal, right? Because what I wanted was that we do that. For at each. At age
I
nine,
wanted to have model for every age.
yes,
That was what you. In the circuit, you break it to every time.
mhm.
And you integrate variables. You take us to this.
So
That's how it works. And then,
Yeah, that was, we said, down the focus of marginal, right?
that's a question of the rest of it.
Yes, so that's why I said, do you want it to give me data?
so Lungile, I think we can stop recording now. I think we're just having
Yeah.
sessions within the room. Okay, thank you.
Okay, so, we could open, so let's.